what it is. It's the network in the building, and we're not gonna be working in the book today unless y'all want to, but y'all know I typically stream Monday through Thursday 8 p.m. Eastern Standard Time. But I said I got some free time and I'm gonna go ahead and do some streaming today, and I'm gonna try something out here. We're gonna do Freestyle Fridays. I'm gonna go ahead. I'm gonna work with GNS3 today. I just felt like GNS3 today. I don't know why. Let's see who we got in the building here. I don't know if you guys have AT&T or whatever, but looked like there was an outage with AT&T. So if your phone was working and you got AT&T, that's why. Looked like it was mostly along the East Coast. I'm not too sure. I'll probably have to check downdetector.com for that. I'll give it a couple minutes here for some people to tune in and stuff. Y'all know there might be some people in here that's like, we got Creed 9 in the building. Appreciate you for tuning in. Native Messiah, appreciate you for tuning in. Like I said, I usually stream Monday through Thursday 8 p.m. Eastern Standard Time, but today I decided to get a little... Oh, I should have probably rebooted this thing because this looked like it's going to be tripping. GNS3 don't look like it want to work with me today. Oh, Jesus. Probably because I got to wait till the VM comes up. The GNS3 VM, I'm not too sure. We'll see. We'll see. I should have had that powered on before I started streaming. But we'll see. What else we got on the agenda? Close that. Nothing really new today. I'm gonna do an internet health check. I don't think there's any updates. Last update was May 24th. I thought this was I guess I'll probably have to go to 1009's website. We'll see. But anyways, we are, like I said, we're gonna just do a little freestyle. We'll just put some drag and drop some routers in there and see what we come up with, man. I'm gonna try to go over the topics we went over this week. We did today. We did some static routes, or this week we did some static routes. We worked with access control lists. We also worked with network address translation. We did static NAT. We did a NAT pool. We remember we had to tie that into an ACL yesterday, so we'll see if we can get something similar to that. But it looks like I might have to either reboot or I know I should have got this thing, man. This is why GNS3, man, listen, man. Jesus. I don't want to get that going. Oh, that's what it is. We'll see. Let's just call it Freestyle 1. And we'll see if that was the issue. Do I want to download a new version? No. Yeah, I think that might have been the issue. I don't see no end devices here. So let me go ahead and relaunch this. Let's see. I don't see no devices in here. I'm gonna relaunch GNS3 and see if that might resolve my issue. Has anybody seen this issue before? Got Lee McMillan in the building. Lawrence Little, appreciate you guys for tuning in. Like I said, I typically don't stream on Fridays, but I said let me go ahead and try to. And I got my stream. This look like it's all slowing down over there. That might have been my my VPN just tearing up this computer here. We'll see though. We'll see. I'm gonna go ahead and relaunch GNS3. See if we can get that going. Professor Black Ops in the building. TGIF. What is up, chat? What's going on, Professor Black Ops? Appreciate you for tuning in. Yeah, check him out. Look at this, man. We got the VM. The VM is coming up, so we'll see. We'll see if we can get this going here. Anyways, what's going on with y'all end, man? Okay, there we go. We got some devices here, man. I'm just like, what is going on here, man? All right. We didn't open one up yet, did we? We sort of did. It was called Freestyle. The VM is powering up, so I'm gonna leave that alone until the VM powers up. I'm gonna leave that alone for a little bit until this VM powers up. But we got our devices coming up. When all else fails, reboot, right? Relaunch at least. The VM look like it's waking up. Anyway, y'all know typically we stream from we typically lab from this book right here, 101 Labs Cisco CCNA version 4. We are almost wrapping this book up. Like I said, I've said this a million times already. You can get a copy of this from 101labs.net, but there's also a link in the description box below. And typically I will use this lab guide, try to complete that lab, and have you guys do it along with me. I get a lot of help from people in the chat over there. But today is a Friday, and I typically don't stream on Friday, so I said I'm gonna do a Freestyle Fridays. Try something new here, where we just try to just drag and drop some devices in there, try to go over some of the topics that we went over this week. So this is something I'm kind of trying new here. I didn't plan any of this. I just said I'm gonna just stream. I just pressed record and said, let's see if we can get something going here. Did I have my, where was it? I thought I created one. Did it show up in there? Did I even have a folder? Nothing? No? All right, so I guess I'll have to create one. We'll call it Freestyle Friday 1. Freestyle 1. Freestyle Friday 1. Let's get, let's do this. I'm gonna have a router in there for sure. Do I want a AAA server? We did some AAA this week, but they had us go over the configs, but he didn't actually have us authenticate to the AAA server. So I didn't like that lab. I don't know if we'll go over TACACS or Radius. Unless we had like Packet Tracer, which there's some functions in there that we could at least do that. And I don't think I have the AAA server fully enabled. So I'm gonna drag and drop another router here. What else we gonna do? What else we gonna do? Do we want 2 routers? We'll try to maybe drop another router in there somewhere in there. Yeah, let's drop another router in there. We'll have 3 routers, even though most of our lab called for only 2 routers. So remember, this was no planning in this stage here. You know, as a network engineer, you want to at least have a planning stage of what you're gonna do. We'll connect that to fast Ethernet 0. We'll go from 0, 0, 0, 1 to 0, 0 on that guy. What else should we do? What else should we do? Let's have a PC somewhere in there. Let's drag and drop a PC somewhere in here. We'll definitely have to have a PC somewhere back there too. Even though we had we was working with loopbacks for the other networks. So what else we gonna do here? Let's set up some natting on this side over here. We'll set up some natting. Do we want to put these? Then we'll have 3 different networks. That'll really make it not confusing, but just, you know, a little bit challenging here. Y'all let me know what y'all want to do. If y'all got any ideas or whatever. Gonzalo in the building. Appreciate you for tuning in. I haven't seen you in a minute. Shout out to Gonzalo Nicolas out of Buenos Aires. It's a VMware microsegmentation. Good combination with Cisco. Yeah, correct. Matter of fact, I just finally got creds to the our VMware Edge device today. I knew it existed. I just didn't have access to it. And I saw somebody talk about it in the chat, and they was asking me, "Hey, do you know the IP, the management IP?" I'm like, dude, I'm the new guy here. How the hell am I supposed to know? But then, you know, I heard them talk about it. They gave me the IP address, and I was like, okay, you know, put that in my little pocket, and then asked them for the creds to it. And it's basically the termination for our direct connect for AWS and stuff. So, what else we got going on here? We're going to use the GNS3 VM for that device. What happened to my other PC? Didn't I have another PC in here? I didn't cable them up. That's what happened. I didn't cable them up. What else y'all want to do here? We'll set up some. We did some static routes. We'll set up an access control list. I'm gonna set up another PC. I'm gonna set up another PC in here. And we're gonna really, we really gonna try to jazz it up here. We're gonna put this maybe in another network or something. Y'all work with me here too, man. Y'all let me know what you guys are doing. I think I'm gonna have one more PC, and then we gonna I don't want to jazz it up too much. I'm put 3 and 4 on this side, 1 and 2 on that side. Right? That's pretty much all we gonna do. I probably should just have just one router. I mean 2 routers, because that might be a little too much, because we got all these networks and stuff. You know, just by the looks of this, you can see we could potentially have how many broadcast domains here? 1, 2. We could have one that is a network, and then this in a separate network. We can do that. So I think what I'm gonna do is I'm gonna remove one. No, I want the static route to really kind of like be able to show us that we can get to another network, because we know this is directly connected, so they definitely gonna be able to reach each other. So that's why I want to have another network there. That's what I'm gonna do. That's what I'm gonna do. I appreciate you guys for tuning in. This is the first segment, or the first Freestyle Fridays. This was an idea I had for a minute, where I said I'm gonna just, you know, just kind of freestyle it, man. Just come up with some devices, go over the topics we went over this week. This week again, we went over. I'm putting that on the gigabit port. I don't want to do that. He's a PC. He don't need no gigabit in Ethernet access, man. Let's connect him to. Do we have another fast Ethernet? Damn, that's all we got. We'll have to go with that. We'll give him a gigabit. That'll be the IT guy. He has the gigabit Ethernet port. He got the fast Ethernet. There's the other IT guy for the other site. Connect him to the gigabit 1.0. Anybody got AT&T? There was an outage. It looked like about an hour or two ago. Definitely in the Florida region. I don't have AT&T. I have T-Mobile. And you know what? I was on the phone with my girl, and she was just like, we couldn't even reach each other for about 2 hours ago. And now that I think about it, I think she got AT&T, and that's probably the reason why. I'm gonna text her and find out, because if that was the case, because she's trying to blame me because I got T-Mobile. I'm like, it ain't my phone, man. I'm over here trying to make fun of my phone and stuff, man. Come on, man, this phone, man. All right, so let's do the 3-tier web app and database. Hold on. What about a mini network? 2-tier or 3-tier? I got plenty of stuff to study. I'm implementing solutions that I've never seen before. Oh, that's what's up, Gonzalo. That's right. You just got a job, right? As a network technician or network engineer. I can't even remember. But I remember we was congratulating you for something. It's just that you haven't tuned in a while. So let us know what you're working on and stuff, man. You ain't got to give us details or whatever, but that's pretty cool, man. Congrats on that. I think this is all I'm going to do as far as the network goes, man. I know you said 2-tier or 3-tier. But this is more similar to what we was working with. Let's put this in the let's work with some public IP addresses too. That's the one thing I didn't like about that lab guide, is they put nothing but everything in the private IP address space. We'll put a /30 subnet here, /30 subnet here, and then for the rest of these we'll do /24. That's what I'm gonna do. So just to give it some realism, we're going to put this in the, let's say this is the 97.55.70.0 network /30. So this is a point-to-point network, right? Y'all know what that is, right? That means we only got 2 usable IP addresses. So in this case, it's going to be, he should be .1. Let's go ahead and put some label in here. Let's put some label in here. There we go. Right? Y'all with me so far? We're going to make this guy .1. That's going to be .2. That's going to be .2. We're going to put this as another network, and that's going to be .1. And that's going to be .2. Right? Y'all with me so far? Can I duplicate that and then change that? We'll make this one the We'll call this the 195 network. Now watch, I'm gonna really fuck it up, man, because I'm gonna be like, damn, what the hell did I do here, man? But it's all good. It's all good. This how we do it, man. We'll put this in the 157 network dot 60 dot 70. Really fucking it up here, man. Woo. We'll see how it works though. This is exactly how we got to learn this shit, man. Y'all let me know what you guys are doing. I put four devices, 3 routers. I'm not putting any switches here, so we're gonna be working with a wide area network here, right? He says cybersecurity analyst junior, really junior. Hey, it's all good, man. We all start from somewhere, man. I'm doing IPS stuff right now. That's what's up, man. I don't even think I've ever touched an IPS device. Now that I think about it. You know, unless you consider not even firewalls an IPS device, but yeah, I mean, at least you're touching that stuff. But that's what's up. What else we gonna do here? Remember, he's gonna be .1, and he's gonna be .2. I'm really fucking this shit up. I should probably get rid of one of these, man, before I really fuck my shit up, man. Nah, fuck it. We gonna work with it. We gonna work with some static routes first, right? We know how to work with static routes, man. I'm gonna add a note here. He's gonna be .2. Y'all with me so far? He's .1. He gonna be .2. He gonna be .2. And then I'm gonna make this the 192, 168 network, and I'm gonna make this the 10 network. Since that was one of my jobs is the 10 network. So this is gonna be the 10.10.252.0 network, right? And then this is gonna be, so y'all, that means we got to do some natting, right? Y'all remember what natting is, right? Network address translation. We got some private IP addresses. We got some private IP addresses that's going to be going over to the public IP address. So this is kind of like, this is simulating the internet, right? And remember though, on the internet or the wide area network, private IP addresses are not routable on there. So we got to do some network address translation for sure, right? What we going to do here? Ooh. That's going to be a tricky one. This is going to be a tricky one. This is going to be a tricky one. How do we make... Okay. We'll just have to figure this shit out. Because if I create a NAT pool and his IP address is 70.1, does he pull... We'll see. I guess we'll see. We'll definitely see. Because that's going to be a tricky one, man. I'm really throwing myself off here. But it is what it is, man. We don't have I guess our end goal is to have these two PCs be able to communicate with these guys using natting, ACL. What else we said? What else we put on the agenda? I don't think I'm gonna do some TACACS and radius because I'm really gonna fuck this shit up, man. It's all good though, but we don't do it, man. Does WAN mean BGP? Not necessarily. We can use BGP in this, but we haven't covered too much of BGP. So I'm going to do some static routes. Since this week, what we covered was static routes. And this is the reason why I said I'm going to do Freestyle Fridays, because we typically stream, what, Monday through Thursday, right? 8 p.m. Eastern Standard Time. So we got a topic on Monday, a topic on Tuesday, so on and so forth. And we get to Thursday, we wrap it up, right? When we get to Friday, we're going to mix all these topologies, mix all of these technologies up and try to use those technologies that we learn. And that's why I said I want to try to do that. But typically Fridays I don't have the time to stream, but I said I did have time today, so I said no, we're gonna try this out. We're gonna try this out, right? Y'all let me know what y'all doing. If you want to use if you want to use BGP in the wide area network, so in this area right here, if you want to use BGP, go ahead and do that. I could probably do that as well, but what's fresh on my mind is the static routes that we did, and that's what we covered this week. So that's why I said I want to try to keep our Freestyle Fridays in line with what we learned this week. So this, again, is going to be the 192.168.1.0 network. We'll do that. He'll be .1 and he'll be .2. Same thing with this guy. He'll be .1 and he'll be .2. Right? So, and then I don't need to put the label there, right? PC1 is obviously going to be .1. PC2 is going to be .2. Let's start with the PCs. We'll do that. Let's start every device. Hopefully my laptop don't blow up. Y'all let me know what y'all gonna do. Again, y'all remember me that like button too. If y'all like what y'all see so far and stuff like that. Like I said, I'm usually teaching you guys what I, as I'm going through this lab book, but we're just kind of putting this lab book on the side today, because we usually lab from this book Monday through Thursday, 8 p.m. Eastern Standard Time. I know I said that a million times, but what else was I going to say about this? Monday, when we do stream on Monday, tomorrow I'm going to stream too. Y'all know Saturdays, I usually don't stream on Saturdays, but I'm going to do Saturday. We're going to go over NAT overload. And that is going to be on page number, what is that? Let's see. Challenge lab number, not 5. Challenge lab number 6, page 491. How many pages in this book? It's about 546. So like I said, we almost done with this book, man. Almost done. We about 90% through this book right here. We're gonna move on to the CCNP topics. Let's start with the PC. I'm gonna console in that bad boy. We'll just do some basic IP addressing here. He said maybe close some background apps. Maybe. Yeah, you're right. I should close the what is this? That is the Discord server. If you guys want to join us on the Discord server, like I said, I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. But today I said I was going to stream at 7 o'clock. Well, I ran into something, and I said, hey, I pushed it back to 7:15. For you to get those updates, you're going to have to join the Discord server. There's a link right there. That's the invite. And you can get updates from there. So whenever I'm streaming on a special day or whatever, if I ain't got shit to do, because, I got a life. Shit, I'm not always labbing, even though I love to lab and stuff like that. Y'all let me know if y'all could see. Let me move all this stuff up so y'all can see everything. Bloop. No, I want to move these guys up. Just these. Come on, don't do me like that. Don't do me like that, GNS3. Y'all know I'm usually using hardware. Y'all know I'm typically using my, what's going on here? Y'all moving shit over? All right. What else we gonna do here? Y'all let me know if y'all got some ideas and stuff, man. Remember, this is just Freestyle Fridays. We just coming up with some shit. Let's start with the IP addressing. I think it's just what, IP, and then you just put in the IP address, and we're gonna give him 192.168.1. He'll be 1. I don't want to give him a gateway address. I'm gonna make him 1.2. Give him 1.2, right? 255.255.255.0. And I'm gonna make him 1.3. Ooh, this is gonna be 2 separate networks. This is gonna be a tough one right here. Not a tough one, but this gotta be .1 and then that's gotta be .1. Unless I put a switch in the middle. I think I might remove that bad boy, because I want to put these guys in the same network. And in order for me to do that, remember, because this is a separate broadcast domain, and that is a separate broadcast domain. So unless I make him 2.0 and make him 1.0, I would have to put a local area network switch to put them in the same broadcast domain. So let's go ahead and do that. I think I'm going to go ahead and do that. Y'all with me so far? So I'm going to put in, let's put in a little Ethernet switch there, right there. And I think I might remove one of those little, I might remove one of these routers, because that shit gonna be way too, not confusing. It's just, I don't want to fuck it all up, I didn't do no planning here. Typically, as a network engineer, you want to plan your network. And this is Freestyle Friday. You should not be freestyling as a network engineer unless you're a goddamn rapper or something. So, we're going to plug him up to that right there. And then we're going to make the switch as the router as 1.1. Y'all with me so far? Y'all see what I'm doing? So now the router is going to be, he going to be 1.1. Boom. We got to do the same thing on this side because these are two separate networks, right? Y'all with me? And then I might just remove that third router. And then we're just going to work with this as the public IP address. Because this shit really going to fuck it all up. Fuck it up, fuck it up, fuck it up, fuck it up. Do I want to do that, though? Because I want to work with a static route, but I want, like, we know this is directly connected. And they're going to be able to ping each other. I don't want it to be that simple. We'll see. Let's work with it. Let's work with it and see what we got. Just remove one of the PCs. The one on the left. Yes, you're right. I could have done that. I could have done that. But, you know, typically you have your PCs connected to a switch, a local area network switch. You don't have them going directly to the router. So, not that I'm adding, I guess I'm adding a little bit of realism here. So, but yes, what Pete said makes sense. I could have just removed one of them and made it one network. I just want to be able to build somewhat of a bigger topology. Y'all know I always work with just like one or two routers, and we don't really do much. So I said I want to try to make something a little bit bigger. Let's delete that right there. Delete this right here. Put the local area network switch. And then, again, this is the 10.0 network, or 10.10.252. Connect him to that. Connect him to this. We'll go from here to here. And now the router, that interface right there is going to be .1. So he going to be .1 right there. Come on, man. Y'all with me so far? Anybody lost yet? I know we haven't done shit yet. We just doing some labeling and cabling. So he's 1.2. The other PC right here, I'm going to make him 1.3. And then we're going to make the router right there 1.1. So I guess I'll work from left to right. I'll do that. I'll do that. For you, those of you guys that are just caught on or that just tuned in, y'all run with that like button and stuff like that. Make sure y'all subscribe. This is the first of Freestyle Fridays, where we just kind of use all the topics that we learned throughout the week, because typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time. And then what I wanted to do was on Friday, take all of those topics that we learned or technologies that we learned and kind of lump them into one topology and stuff, right? His IP address is going to be 192.168.1.3. Subnet mask of 255.255.255.0, right? I'm not going to put any address in here. We're going to leave the switch as is. So now I'm going to make the router. This right here is going to be .1. So he's going to be the gateway for these two guys right there. And then we'll have the router ping that right there. Right? Y'all with me so far? So I'm going to console in the router 1. Console. Once we get to the other side, then probably we'll work with some static routes, left to right. Maybe some ACLs, left to right, and see if we can telnet from one to the other. We gonna fuck it all up, man. Not fuck it up, but we gonna do what we do. We gonna do what we learned this week, right? So we know this is router 1, obviously. Interface FA01 is right there. We need to make that as the gateway for the devices on the left, right? Interface FA0/1. His IP address is gonna be 192.168.1.1. Subnet mask of /24.0. No, shut that bad boy. We'll see if the PC can ping his gateway. Oh, I didn't make him a gateway. I didn't give him a gateway. How can I give him a gateway? Let's see. Let's do that. I want to make him his gateway. You got to put in IP, the address, IP question mark. So let's see, because I can't remember the syntax for it. Okay, so IP, the address, subnet mask, and then the gateway, I believe it is. Is that what it is? I think that's what it is. So we're going to say IP 192.168.1.2. And then what? The gateway? no, /24 /24, and then his gateway is 1.1, so 192.168.1.1, like this right here. Boom. And now show IP, which I learned the other day on this. So now his IP address is 1.2. His gateway is 1.1. We ain't worried about no DNS. We ain't got no DNS server, so we'll leave that as is. Y'all with me so far? Right? Simple shit right now. We ain't do no routing yet. We didn't do set up no static routes or nothing yet. Let's go to PC2. Give him the same thing. Not the same thing, but we'll say /24, and also give him a gateway of .1. So 192.168.1.1. And then I'm going to have him ping that, and then I'm going to have him ping the gateway. So let's go back to PC1. I like what I'm doing here. Now I'm kind of planning it, but I'm just going, I came up with a plan by going from left to right. This is why I like this is just like freestyling, right? So 192.168.1. Let's see if we can ping him, right? 1.3. I don't think I can because the gateway's not up yet. Oh, it should be. 1.3. We got to reply. No, that's myself. Let's see. Who's 1.3? Yes, he's 1.3, and I'm 1.2. Yes, so basically I have him ping him. So he's good to go. Can he ping the gateway? Let's get on our knees, pray to the network gods, press enter. He can ping the gateway. So he can ping the gateway, boop, and we'll see if he can ping the gateway that way, right? PC2, ping the gateway, ping 192. Theoretically, he should, right? Because bidirectional connectivity, right? 1.1. He can ping the gateway. So we good to go. So we got this right here. This local area network is good to go right here, right? We'll even put that in let's put these guys in the network, right? We'll do that. Let's do that. Bring him over this way. Y'all got any questions so far or whatever? I hope you guys are not necessarily follow along, but at least freestyling with me. Remember, we're doing static routes, ACLs. We're gonna try to do some natting. Fuck it all up with NAT not an overload, but NAT Pool. Let me see here. Style. We'll give him the color of teal for now. That's the fill color. Apply. Okay. Lower this bad boy. Boom. There we go. So we done with that network right there. That network, we got some basic connectivity in the local area network here. So now let's go ahead and have some static routes here, right? We got that going. Let's see if we can have, let's do this network right here, right? This address, that's that address, right? Y'all with me so far? Let me know if I'm losing anybody. Like I said, I know that y'all might have some different networks because this is about freestyling, right? If we had a freestyle battle, right, and I'm spitting some words, whatever, and you're not gonna spit the same exact words as me, right? Because we think differently, right? I might be left brain, you might be right brain. You might be a gangster rapper, I might be more conscious rapper, whatever, right? We gonna freestyle differently. So whatever you have in your network topology is gonna be different, but at least come up with something that's not necessarily similar to this, but at least that we're gonna try to put in some static routes. We're going to try to put in an access control list somewhere. Maybe we'll have only PC1 can ping that guy, or only PC2 can telnet to this guy, etc., right? And that's what we're going to try to do here, because that is the topics we learned today. Static routes, ACLs, and natting. We also did some TACACS and radius, but that shit kicked my ass this week, so we're not going to go over that. Plus, I don't have this AAA server fully enabled. I haven't really learned how to use that in GNS3. I ain't gonna front for y'all. I haven't learned how to use that really. So, what we said we're gonna do here. Cisco switches are super expensive. You're right, they are. Depending on which model you were talking about. As a matter of fact, I remember putting in a quote at my job. We had some really old switches in one of these network closets, right? And it is one of the main hubs for this building. So I'm like, oh, this shit gotta go. So I reached out to the vendor that we typically use to order some stuff. I asked my supervisor what model we wanted. He was like, let's go with the 9200s, which is basically, it's not Cisco's flagship local area network switch. It is kind of their flagship switch is the 9300. If you're really familiar with their line of products, right? The 9300 is a really beefy switch. They took basically all of Cisco's best features and technologies and put them onto this switch. If you know anything about the 9300 switch, I used to deploy them at my last job. Great switch. And we did it for the hospital system. They got like over 9 hospitals in the Central Florida area, and plus 300 remote sites. They were deploying these switches. So it's a great switch, standard switch, right? We're ordering 9200s, which is a little bit stripped down with the features and stuff like that. But that model alone is like was it like 8,000? No, it was like 4,000, 5,000, I believe. And that doesn't include any like licensing or anything like that. And it was just the 24. No, it was the 48 port model. And but the 9300 is about 8,000 alone, and that's just like without all the licensing and stuff like that. So yeah, switches can be super expensive. So where was I? Let's go to router 1 and do what we was going to do. So we need to go to that interface right there, FA00 interface FA00. Give him the IP address of 97.55.70.1, right? With the subnet mask of 255.255.252/30 subnet, right? Ambiguous command. That's because we gotta actually type in the whole address or at least something to make it unique. There. Now he's got that IP address. We'll no shut that bad boy. And I'm gonna bring this one up and then see if they can ping each other, right? So he's up. Let's go to router 2. Console into that bad boy. More BGP. Yes, we do need some BGP, man. Yeah, man. And then I ordered 6 of them, bro. Really, I ordered 5 of them. And we ordered a 6th one for expansion. So that's another tip for you guys if you're like becoming a network engineer and stuff like that. Finally take them. Yes, Kelvin. Shout out to Kelvin Tran. He is, y'all join his, y'all subscribe to his channel. He gives me a lot of advice and stuff like that, and said the best way to learn this stuff is to kind of freestyle it, man. Just come up with your own network topologies and just kind of like see how things work. Don't just go by. It's like this book that I love. This book, y'all know how much I preach about this book. I promote it like it's like I wrote the damn book, right? But it's kind of like it gives us a script to follow, right? We don't want to be robots as a network engineer. We want to be able to jump into a network and be like, okay, this is working because of that, or that's not working because of that, or this is broken because of that, whatever, right? So, us being able to just come up with networks on the fly like this and being able to troubleshoot them this way makes us a better engineer. So, yes, Kelvin, I'm finally taking your advice. I said, this is what we're going to do. We're going to try to do what we do Monday through Thursday, learn what we can from these books and stuff like that, and lab from the books, and then take those, what we did on Monday, on Tuesday, Wednesday, Thursday, and then on Friday, we're going to take all those technologies and try to come up with something, and that's what we're going to do on Freestyle Fridays. This is the first Freestyle Friday. Y'all know what it is, man. Y'all hit me with that like button if y'all like what y'all see so far. So, router 2, we go to global config mode. We're going to give him that IP address right there, right? 97.55. He's going to be .2, right? Because he's .1. And we're going to do the same thing on NAT network. I don't know. I may or may not get rid of the router 3 right there because this is going to make it a little funky, but it is what it is. Interface FA00 on that guy. His IP address is 97.55.70.2/30 subnet 252. No shut that bad boy. Let's see if we can ping the other side, right? I'm going to have router 2 try to ping router 1, right? And he's 97.55.70.1. Do we have a reply? We do got a reply. I was getting scared there, man. Got on our network, got on our knees and prayed to the network guys. We got a reply. So he can ping him. Theoretically, the other guy should be able to ping the other guy as well. Ping 192. Not only that, Kelvin, I'm using GNS3. I'm not using my hardware. I didn't feel like doing any cabling. Plus, being that I'm freestyling here, y'all wouldn't be able to see the topology, obviously, unless I like pointed my camera to the routers and switches and stuff like that. But obviously it's going to be better for you guys to see it this way, right? And maybe I'll start using even G again, because I know Endrit he hasn't tuned in for a while. He showed me how to use it, and it's just like, man, you need to use even G. That's the wave right now, man. He's going to ping 97.55.70.2. We got a reply. Good to go. All right, so these two are able to ping each other. Let's do some basic connectivity here. Then we're going to have to do some static routes. So we need to get some IP addressing here, IP addressing there. We'll have to do some static routes, and then we'll go with the ACL. So we're done with these two guys. Now we're going to No, I need to do this interface right here. Let's go to router 2. Let's go back to router 2. Configure terminal interface. Y'all let me know what you guys are doing. It don't have to be exactly like this. Remember, just like we freestyling. You're not going to spit the same verse I'm spitting, right? So just at least try to do something with static routes, ACLs, and NATing. NATing is a tough subject for me. It's been a sticking point. But luckily I got my man Kelvin over there to help us out like we did yesterday. FA01, his IP address is going to be 157.60.70.1/30 subnet.252. No shut that bad boy. We're going to go to router 3, do that IP address, console. And after that, we pretty much console. No, we didn't console into every device. We got to still do these two guys right here. Still got to do those two guys right there. I appreciate you guys for tuning in. Y'all remember that like button if you like it. Y'all like what y'all see so far. If you're just tuning in, what the fuck is going on with router 2 here? He talking about some extreme. What the hell is this? Oh, I don't know what was going on there. I guess I was typing something there. His IP address. We're gonna do this interface right here, right? Y'all with me so far? FA00 IP address of 157.60.70.1/30 subnet. No, he's not .1. My bad. He's .2. Right? Fat Finger Squad in the building. 255.255.252. Oh, that overlaps. Interesting. What happened there? What happened there? I'm on router 2. Oh, I was supposed to be on router 3. My bad. I'm on the wrong device. Boom. That's what happened. My bad. My bad. I hope I didn't take that IP address. Let's check our work. Y'all see what happened there, right? I consoled into router 2 twice. So I didn't realize that, right? So show IP interface brief, exclude unassigned. Good, he didn't take that IP address. So let me close that, go to router 3, and configure that interface. Interface FA00, right? This was the interface I was trying to configure there, right? Right? His IP address is, again, 157.60.70.2/30 subnet. If you're just tuning in, go ahead and drag and drop some routers similar to this, or at least a network topology similar to this. Go ahead and try to put in some static routes between the networks. We're going to work with some ACLs, and then we're going to try to do some NATing here. Notice I've got a public IP address here, a public IP address space here, and then we got a private IP address here, and a private IP address space there, right? Why? Because we're going to try to practice some network address translation, and I didn't like the way the book had us practice NATing with all private IP addresses. So we're just trying to add some realism here, right? No shut that bad boy. Try to have router 3 ping router 2 and vice versa. So I'm going to ping 157.60.70.1. Get on our knees, pray to the network gods. It's hanging there. We got to reply. Good. Let's ping it again because we want to see 100%, right? Good to go. We'll do the same thing on the other side. Ping 157. Is theoretically should work, right? 70.2. We got to reply. Good to go. So we got connectivity here. So all these guys right here work. We got our wide area network going here. Let's go ahead and create. We're going to work on the gateway right here, right? The gateway for these two guys right here. This local area network is 10.10.252.0, right? So go back to router 3. That gateway is going to be .1, right? And then we're going to make PC3 as I'm gonna make him. He's gonna be .3, and the PC4 is gonna be .4, right? That's what we're gonna do. That's what we're gonna do. I should make him. Yeah, we'll do that. So interface. What interface is that? I don't even know what interface that is. What interface is that? Let's see. Show IP interface brief. Which one is up? None of them. Huh? Interesting. Interesting. How am I gonna know what interface that is? Ah! Oh, you know how? Move the shit over. It's FA01. That's what it is. Y'all see that? That's how I was able to figure it out. So it's FA01. Good thing we have some labeling there. Labeling and cabling. Labeling and dabling. Wheeling and dealing. He said create a DHCP pool for the PCs on the right. You want to do that? Yeah, let's do that, Pete. That's a good idea. Let's create a DHCP pool. Let's do that. Let's do that. Do routers? I guess that'll answer my question. And I like the fact that you threw that in there, man. A little freestyle right there. That's kind of like when people are freestyling and stuff, and then somebody give them a topic, and then now you got to try to rap about that topic kind of thing, right? NAT with private is useful. Shout out to Pepper Jack in the building, man. Appreciate you for tuning in. I haven't seen you in a while there. If you have a cookie cutter branch office like a gas station, then you can have the same IP address space in all the networks, and the branch office will not NAT over the VPN to headquarters. Most of the Gamer said you could also use CDP. Appreciate you for tuning in too, Most of the Gamer. But you said, yeah, NAT with private is useful. Yes, it is. Okay. Oh, yeah, when you're using with VPN. Yes, I see what you're saying. I see what you're saying. If you have a cookie cutter branch office, like a gas station, then you can use the same IP address space in all the networks, and the branch office will NAT over the VPN to headquarters. Okay, I see what you're saying here. So, yeah, we haven't done too much VPN or anything like that yet, so this is why I'm trying to make it like that, where we have the private IP address space going over the public IP address space. I see what you're saying, though, because I know at work, when I'm VPN to my job, right, and I'm at home, if I do what's my IP, it's going to give me a public IP address as opposed to the private one. And even though when I go on my network and I do IP config on my local PC, it's going to give me a local IP address. So I see what you're saying. But we haven't really worked with VPN yet, so that's a little bit beyond my skill set right now. But good point there, Moose of the Gamer. I mean, not Moose of the Gamer, Pepper Jack. So yes, I like that idea. Pete, let's have router 3 do some DHCP here. Global config mode, IP DHCP pool. We're gonna call it the 10-10- pool. Network address space. But I don't want to give him, so I'm going to have to, that's what I was going to say. I don't want to give anybody the .1 address, so I'm going to have to exclude that. I got to remember that. So 10. For those of you that are new or don't know about that concept, basically we're going to set up DHCP here. Even though we didn't really learn about DHCP this week, we're going to add that in there, right? DHCP is a protocol that we use to kind of hand out IP addresses, right? Notice how I had to give him an IP address manually. Give him an IP address manually. Well, you know what? We're going to have this IP address handed out once these two guys request it, right? And then, but the thing is, you typically want your gateway to be ending in .1. I don't want that IP address handed out, so I'm going to have to exclude that address, and that's what I'm going to do there, right? So the network is the 10.10.252.0 subnet. We're going to say the default router or the gateway is going to be 10.10.252.1. What else we want to do here? So we got a network address space. We got a default gateway. We don't need to do DNS. What else do we need? A lease. We should do a lease for Professor Black Ops. We'll do a lease. We'll give it a lease of 5 days, right? 5, right? Right? Because the first number is days. Yes, 5 days. Actually, we'll give it a 10-day lease. 10-0. That is the lease. What else we want to do? Let's exclude the .1 address, right? So we're not handing that out. IP DHCP excluded address is going to be 10.10.252.1. Right? Let's take a look at our work. Show IP DHCP pool. What is the pool? We're going to hand out through here. But I don't like the fact that it doesn't tell you what IP address is going to be excluded. We excluded, we put the /24 subnet. We did do that. But it's going to hand out everything from there. We said 10.252. You know what? We got to actually do the subnet. Let's go back to that pool. Y'all see that? The range is from 10.0.0.1 all the way through that. We don't want that. That's going to be the gateway. I wanted to, we got to make it /24 to make it like that. Right? Y'all with me so far? This range is wider than what I thought. So I want to make it a smaller network pool. So we're going to go config mode, IP DHCP pool. The name of it was what? We said 10-pool. Right? Is that what it was? Was that what the name of it was? Yes, 10 pool. And then we're going to say the network, was it the network address space? Yes, network is 10.10.252 because that was the class full network. That's why I did that. We got to put in the prefix. So we're going to put in a cider notation and say /24. Now we do a show IP DHCP pool. we'll see the range is a bit smaller. But we excluded it to 10.252.1. It don't say it in this pool right here. I know on switches, I think it'll tell you the excluded address. But on a router, I think you actually have to do show IP, DHCP. What is it? Database, import, pool, nope. So you actually got to do show run and then include DHCP or section. Now you could do section DHCP. He said true. Then you can use automation on the building, building the network. Yes, I see what you're saying. Yep, for sure. For sure. Put Mama's cooking on security. Shout out to the lease, man. Yeah, for real, man. I remember you said that last time, but we'll do a lease this time. Throw in SIP DHCP option 120 for our VoIP phones. We might add later. Man, Pepper Jack, you doing too much, man. We should do that, but we didn't learn anything about VoIP this week. We didn't do any kind of SIP trunks or nothing like that. But I'm throwing in a little bit of the DHCP. Only because I know a little bit about it, or more about it. I don't really know that much about SIP trunks, and my VoIP is not that strong. So, you got to do show run and then pipe section. We'll do DHCP like that, and we'll pull up all the configurations for DHCP. I had to put it in lowercase. That is the excluded address. So theoretically, it should not hand that out. So now, if we go to these PCs right here, request an IP address. They should theoretically obtain one. So let's do that. Let's console into that bad boy. Console into this bad boy. Y'all with me so far? Y'all with me so far? Again, we're just freestyling here. Y'all remember me that like button, man. But I like that you guys are throwing in some ideas. Once we get to, once we start doing some more VoIP stuff and start adding phones, does GNS3 add phones? Does it support VoIP? I don't even know. I don't have a phone appliance or anything like that. But yeah, once we start learning more of that, like I said, I want to, on a Freestyle Fridays, I want to go over the topics we learned throughout the week. So Monday through Thursday. This week we did static routes, we did ACLs, we did NAT, static NAT, and we also did a NAT pool. So those are the topics that we're going to go over. We did some radius and TACACS, but like I said, I don't know how to use the AAA server. So I ain't gonna front. So IP DHCP, or is it just DHCP? It don't look like we are getting an IP address. Theoretically, it should have said DORA, which stands for what? If we were gonna get an IP address, see, he can't find the DHCP server. He can't find the DHCP server. Let's go to router 3. We got some configuring to do here. I think that's the reason why. We said the default router is going to be 252.1. Well, who the fuck is 252.1? We look at our interfaces on this router right here, router 3, right? Show IP interface brief. We don't even have that IP address assigned. See how immediately I found that problem? That is the reason why. That's why I can't find a DHCP server. He don't know who the fuck it is. Let's go to the router, and we're going to configure that interface right there as 252.1. And theoretically, it should work. So interface FA0/1, we'll give him the IP address of 10.10.252.1, subnet mask of /24, which is .0. No, shut that bad boy. Now let's go back to the PC. Have him request a DHCP address, right? How we did that with IP DHCP. We got a D. Pause. Now we got a DORA. Beautiful. We got an R is waiting there. He can't get an IP address. Now we got another problem. Y'all know what to do. So we're stuck at the R portion of the DORA. What does that stand for? Does anybody know? Pete said, also, let's add in the ISP network to this lab. You can do VoIP in Packet Tracer. Yes, you can. But y'all know Packet Tracer is a junior application. We kind of graduated from that. But yes, you can do VoIP. And maybe we'll do that. We'll do that maybe in the next Freestyle Friday. And an Ice Lab. Lawrence, you like that? I was talking about DD pod. Anyway, so what are we missing here? We got a D, we got an O, we got an R, and we got stuck at the R. What does the R stand for? Does anybody remember? A lot of cursing in this lab. I love it. Don't ever change that, bro. Hey, listen, man. I'm gonna keep it real, man. I'm gonna keep it a buck. I know there's some people that be like, man, you need to keep it professional and stuff like. I'm gonna keep it a buck with y'all, man. Like this is how we do on this channel, man. I'm just trying to be different, man. So we're stuck on the R portion. What does the R stand for? Does anybody remember? Musa the Gamer got it correct, and so did Lawrence Little. The R stands for request. When we're looking for an IP address, we discover. The D stands for discover, not what you think it is. The D stands for discover. We're discovering for a DHCP server, and that's what we did here. We got stuck at the D, and we couldn't find the DHCP server. Okay, well, cool. We went in. We knew the problem. We needed to put a gateway there. We gave him the gateway. We said, okay, cool. D, which stands for discover. So we found it. Now the O stands for what? Offer. Now the DHCP server is offering us an IP address. Well, that's great. We got the IP address. We liked it. We requested this IP address. The router was just like, you want it? And it got stuck there for some reason. So we went from D, discover, and then he offered us an IP address. We said, okay, we like it. We like this lease, 5 days. That's perfect time for us to get on the network and search for what we need to search for and go on Pornhub and stuff like that. And then we requested it and it got stuck there. We needed an A for acknowledgement. So that is what we're missing. We need to go on the router and figure out what the hell's going on here. So let's see here. Let's see here. We need to look at our DHCP pool. What do y'all think is wrong with this DHCP problem? Let's see. Current index is .3. We leased one address, so we gave him an IP address. That's weird. That's weird, but he said we leased an address, but he didn't acknowledge it. Why didn't the router acknowledge it? That's weird. Let's go back to the PC. Let's see. He couldn't get an IP address, though. So, show IP. Nope. He didn't get an IP address. But for some reason, the router says he leased an IP address. What did he lease? It definitely wasn't .1 because we excluded that from being handed out, right? Remember? We excluded 252.1 from being handed out. We said don't give that IP address away. Let me see. He said, not me. Do you? Yeah, for sure. No, I feel you, man. Yeah, no. There's just some. I mean, I haven't gotten that complaint yet, but I there's another YouTuber that I see. He does kind of get. He's a little foul mouth or whatever, and I see a lot of complaints. I'm like, man, let him do him, man. It is what it is. A couple YouTubers, so hopefully I don't get any strikes or anything like that. Utilization 100%. You think so? You think so? We said we gave him the network of 252.0. What does the pool? What does the pool have? 252.1 is the starting address. We have a total addresses of 254. So no, we didn't get 100% utilization. That is the utilization mark. That's I see what you're doing there. I see what you saw there, but that's the utilization mark. I think that is when we're at 100%, it's gonna let us know. But we have 200 IP addresses that are available to be handed out. We leased one. I don't know which one the hell it is, but we should be able to hand out IP addresses between this range right here. Is the IP address already assigned to something else? Good question. Good question. Let's check PC4 and see what his IP address is. I don't think he requested one though. Show IP. No, he got 0. FA01. What is FA01 on the router? I'm sure we said that is 252.1. Show IP interface brief. He's 252.1 for sure. And we excluded it from being handed out right here. 1010 252.1, right? 1010 252.1. I don't know if the PC can ping the gateway. Let's see. Can he ping the gateway? Can he ping 1010? Probably not because he don't have any IP addressing. 252.1. No, he's not going to be able to. Not reachable. It is up though, right? Let me see. Yes, it is up. So the gateway is up. FA01 of router 3 is up. That interface right there is up. So what is wrong? What is wrong? Why can't he hand out that IP address? Let's make another request. Let's make another request and see if he'll get it this time. DORRR. It got stuck. I don't know why. That's crazy. That's weird. Is it the switch? I know GNS3 be having some bugs. I probably, I don't know, man. I don't know. Sometimes the GNS3 be having some bugs. It should theoretically work. Do these PCs have release renew command? Good question. I think they do. What are the... I don't know too much about the commands on the VPCS. Shortcut is IP DHCP. That is. You can do disconnect. No. We haven't even got to the static IP routing yet. We can save the config, set the name. We could do the show. Ain't nothing to release though. I see what you're saying, but ain't nothing to even release because I even made another request. So, and obviously he don't have an IP address, so ain't nothing to even release. But good point though. He knows who his DHCP server is. 10.10.252.1. What is going on here? What is wrong? We're stuck in the DHCP portion here. Y'all run with that like button if y'all like what y'all see. But if y'all got any ideas, y'all let me know. I think it's a bug. Same thing happened to me when I was using a router as a DHCP server, but not on a multi-layer switch. Try DHCP -R on the PC. All right, I'll try that, but I'll try that, and then after that, I'm gonna get rid of the switch. If it worked, then there's definitely a bug, and that's why I be hating. I got a love-hate relationship with GNS3. We'll find out though. Let's see. You said DHCP -R. DOR. It gets stuck on the R part. What is that even? What does that even give me? DHCP. Those are the options. Interesting. I guess that's a release, but he couldn't get the IP address for some reason. Fuck this. I'm gonna get rid of this switch real quick, or at least I'm gonna disconnect it for now. We'll get rid of it. We'll get rid of it. We'll get rid of this. Switch 2. Delete that guy. For now, right? Then we're gonna go from here to the gateway. We're going directly to the gateway. If this worked, y'all know how I feel about GNS3, man. I like it, but I hate it at the same time for these little reasons right here. Because with the theory that we know and our knowledge about DHCP, we know that it should have gotten an IP address. We saw that the gateway was down. Okay, fine. We brought it up. We gave it an IP address. We're able to see it. We discovered offered request, and it gets stuck at the R for some reason. Why is that? Either we don't know what the hell we're doing, or there's a bug in GNS3, and we're about to find out right now. We'll go to PC router 3. Let's just make another request, and if it works, pray to the network gods. DOR, and it gets stuck at the R. So that wasn't the problem. It wasn't a switch. So I'm gonna put that back. That wasn't the problem. So let's do that. Get rid of this. There's definitely something. Anybody else has any ideas on why DHCP is not working? If not, then we're just going to have to manually configure that switch. I mean, that PC, and manually hand that out IP address. Or manually set that IP address. So it wasn't a switch. Looked like it wasn't a bug. Y'all know I like to defer to that as the problem. Like, damn, this ain't working. It got to be a GNS3 bug. No, motherfucker, you don't know what the hell you're doing. So connect that bad boy to this guy to that guy. He said yes on the PC, but this switch in GNS3 cannot be configured in the real world or different emulator than yes. Would IP address, helper address on the switch VLAN 1 help forward those packets? Replace the router with a multiple layer switch. We could do that too. But then we're going to have to do all our work with our IP addressing over again. But yeah, let's see. Because I don't see anything else wrong with what we did here, right? We go to the router. We checked our DHCP pool, show IP DHCP pool. Everything looks fine with this IP address. I know Pete said he thought it was a utilization problem, but it says here we have 254 addresses available to hand out. So that's not the issue. This says utilization mark. So high, meaning 100%, and then low, obviously 0. So that's kind of like the threshold. You know what I'm saying? Subnet size, it says 0. Maybe that's the problem. No. First 0, next 0. I don't think so. We leased 1. Pending event none. 1 subnet is in the pool. Current index 10.52.3. So that is the start mark, right? What happened to 10.52.2? That's my question. So we said the first IP address is .1. We excluded that from being handed out. Theoretically, .2 should be handed out. Let's take a look at our configs again. And if that's not a problem, I'm going to go with a multi-layer switch like I said. Include or section DHCP, right? I know you said something about a helper address, but there was no configs. Like he said, there was no configs on this switch. So this is almost like acting like a hub. We didn't do nothing. Pretty much, we didn't do nothing different with this switch. The lease is 10. The default router is that. The subnet 10.10.252.0 excluded that. Yeah, that all looked good, man. That looks good, man. Let me take a look at this switch though. Let me take a look at that. Let's console into that bad boy. See what the hell going on with this. We removed it. I don't think there was nothing wrong with the switch. I'll remove. You know, we're gonna replace that router though. We'll see if there's anything with that. Console. Come on, man. Come on, man. He said we could try debug. Yes, that's a good suggestion too. And see where it's getting stuck at. That is a really great suggestion. Let's do a debug on the router. Debug IP DHCP server. I guess so, server. And then what? Events. Packet. Decode the receptions and transmissions. Events. We'll do events. Can you just do all? Debug. You can't do that. Packet. This is message receptions and transmissions. We got expiration, address assignments. Let's do events. We'll do events. We'll do events. That was a great suggestion, guys. I'm gonna go to PC3. Request that. Let's go to PC4. Let's see. Let's make him make a request. IP DHCP D. He getting stuck at the. He getting stuck at the R2. He getting stuck at the R2. So now go back to the router. Let's see. Let's see what happened here. Sending notification of discover. We added a binding. Notification of discover. We got an assignment. We gave him a lease time. We gave him 252.3. That's weird. That's weird. Let's do that again and add not just the events, but we'll do packets. And after that, we just gonna move on and replace it with a switch and see if that works. And remember, there's no end to this lab. We could just freestyle all night if y'all want to. But this is just some experimenting we're doing here. And you know, if you don't have like the experience to, you know, like doing this in the workplace or anything like that, or if you don't have a job like this, this is how you kind of learning it. I don't really do this at work, and yet I'm a network engineer, but I don't really get to experiment with DHCP on an iOS like this. Yes, we do have some like Windows servers that we use as DHCP, but how often do I use it? Like it's already automated. It's kind of like set it, forget it. Once we have our DHCP server set, boom, there ain't no real troubleshooting we have to do. Sometimes I might have to go on there if we do have like some kind of IP addressing problems. I'll go in and be like, okay, and be like what Pete said. Are you running out of IP addresses? Check the utilization. We have plenty of IP address space, so that's not a problem. And then I don't really have to be on the DHCP server. So we'll make that a request again on PC1. Go to the router, see what's happening. Unicast boot reply. Removing the ARP entry. Let's see. So where was the issue there? So we sent the offer 10.10.2.2. Removing ARP entry. For some reason, he removes the ARP entry. Unicast boot reply, 252.2. Gave him the 252.2. We gave him a leaves time. He sent the acknowledge right there. That is what we're looking for. If he sent the acknowledgement, why is he not getting an A? That's my question for y'all. See, it says right here, sending DHCP ACK to client. That ACK right there lets us know that the acknowledgement went through. Or at least it was sent. So it's not being received by this guy. That's the problem. Right here, the request is received from the client. ACK to the client. That is the final stage right there. That's the A that we're looking for. Request, receive. So the last thing that happens here is that it removes. It does a unicast. He gives him .2. Do we have the .2 in the pool? We do. We do. When we do a show IP DHCP pool. Anybody else got any suggestions? I didn't intend to get us off track with DHCP. You can move on if you want. If it is a bug. He acknowledged .2, so he got a .2. That's what I thought. That's what I thought. But when we go to PC3, we see it's still stuck at the R. He's not getting the A. So, yeah, we might have to manually. This is what I'm gonna do because I really want the DHCP to work. I'm gonna remove this. We're gonna put a multi-layer switch. If that don't work, then we definitely know it's a bug. We know it's a bug. So let's do that. I'm gonna delete these connections right here. That way we ain't got to configure all these guys, right? Let's delete. We're going to delete this. We're going to delete that. Delete this. Delete that. That way we ain't got to really configure those bad boys over again. Save him there. We'll put the multi-layer switch, which used to give me issues. Well, that's why I started. That's why I stayed away from GNS3. But either way, we're going to get it going. We're going to get it going. We want to give him a box just like that so that way we know we're done with it. He is .1. He should be .2. And then we'll put this. That's two separate networks. But either way, we're going to give him the interface VLAN 1. That's what we're going to do. We're going to give him the interface VLAN 1. So that's going to be his management IP address. Hopefully, this router of this switch does not access control list, but NATing. I don't think it does NATing. We'll see, I guess. Yeah, I don't think it does NATing, so this is really gonna fuck us up, right? It's all good though. Start console into that bad boy. Y'all run with that like button if y'all like what y'all see. Typically, we stream Monday through Thursday, 8 p.m. Eastern Standard Time. But today's Freestyle Friday, and we're just kind of going over the topics we learned Monday through Thursday. Here is the Discord server in case I do any cancellations. Kobe says he thinks it's a bug. I think so too. Dave W, he said he lost. Dave, we're pretty much freestyling today, man. Why is there 2 MAC addresses? Yulian, good question. It is because he has a MAC address and he has a MAC address. You saw 2 separate MAC addresses? Is that what you saw? I'm gonna go back to what you saw there before we go back into that switch. You saw 2 different MAC addresses. I think you saw it on router 3. You saw one ending in 68.02. Replied to client that, and then he replied to 68.68.02. Good catch. Good catch. Interesting. What is PC3's MAC address? IP, show IP. IP. He is ending in 6802. He is 6802. What is this guy's IP address? He is 6803. Well, it's supposed to be, it's pretty much this right here. 666803. And the other guy is 666802. Right? That's their MAC addresses, respectively. We'll go to router 3 and we'll see, what was it? 686802. And then he replied to him at 686802. 666802. So, and I think that has something to do with like maybe the VLAN or something. I can't remember what that number is. They appended a number at the end for some reason. I think that's a VPS thing. that PC thing right there, just to give it a unique MAC address. But that's a good catch. I think, who was that one though? 0100. He sent let me see, an acknowledgement to checking for expired leases now. What the fuck? Oh, because I moved the router and he don't see those PCs anymore. Nick's getting their ass kicked right now. Here they are, getting surprised that they was able to. Yes, but only PC3 was requesting an IP address. You're right, but earlier maybe if you tuned in a little later, I did have PC4 try to request an IP address as well. Remember? Look at PC4. We made that request. Where did we do that? Right there, and he got stuck. That was from earlier, and he couldn't get an IP address as well. So unless you missed that part, but let's go to the switch and try to configure that. We're gonna make him .2, that IP address .2, and then we're gonna give him the interface VLAN of 252.1. Right? Y'all with me so far? So yeah, Dave. All we're doing is taking the concepts we learned this week, Monday through Thursday, which was static routes, ACLs, NATs, and NAT overload. And then we're just going to kind of freestyle, put all those technologies together, see how they work with each other, see how they intertwine. We didn't do DHCP, though. Pete S. kind of threw that little wrench in our little topology here. For some reason, the switch don't want to wake up. And we're kind of stuck on DHCP for some reason. But it's all good. We're going to get it going here. The switch don't want to wake up for some reason. I don't know why. I guess... we just gotta wait. I got a slow laptop. Y'all know I got a slow laptop. I don't know what my utilization is. Let's see. There it is. It's finally waking up over there. Y'all see it? It's finally waking up. Where my utilization at? Oh Lord, I need to. That's my issue right there. Look at my PC, man. 100% CPU. That's crazy. We need to do what? What's that? The idle PC, auto idle PC. That's really fucking up my CPU there. We'll stop the stream once I get tired and we're running out of ideas. Auto idle PC for that one. Bring my CPU down. Pete says, "Sorry, it's all good, Pete, man. It's all good. I like messing with DHCP and stuff. So I said we're gonna try to throw that in there. Even though, like I said, we didn't go over DHCP this week, but we definitely went over it a couple weeks ago. So that is sort of a topic that we go over. Can you do the idle PC on this right here? No, you can't. And you can't do it on the actual PC either. I think you could only use that on what's that? Dynamics. So I need to do that on this guy, auto idle PC. And that theoretically should, in case you guys don't know, if you're just like using GNS3 or whatever and you're not, you don't really use it very often, but that is the way to that is a trick that I learned. I forgot where I learned that from. Like somebody came on my stream and told me about that. I'm still at 100% CPU. That's crazy. It's something, yeah, see, I need to do something. My VMware workstation is definitely using utilization, man. Y'all see that? My memory is at 86%. I need to get a server is what I need to do. And I'll probably do that soon. I need to do that soon. I'm running this on the laptop, y'all. So that's probably why I don't need to do these huge topologies. Look at that. This switch is still waking up, man. Look at that. It's like, man, it's 8 o'clock on a Friday. You got us over here 9 o'clock on a Friday. Holy crap. Y'all give me a second. I'll be right back. My bad, y'all. All right. So, quick Chrome, Adobe, Discord. All right, we'll do that. Let's try that. But just in case you haven't been on, is it Switch still waking up? He finally up. This is the Discord server in case you guys want to join. What else we need to quit? He said Adobe. Well, I can't do Chrome because I got whatchamacallit in there. Let's see. Let's see what else we got. Definitely Discord was definitely using up a lot. Whoo! Look at that. That's crazy. This that's definitely my Chrome not really using that much, man. Look at that, 3.4%. That ain't really that much of an issue. It's really GNS3. I'm streaming here. This is just a laptop. I definitely need to get a server though. So let's go to global config mode. We're gonna do that interface, which is GI00. His IP address is gonna be 157. Oops. Oh, we gotta do no switch port. No switch port. IP address. Y'all see what I did right there? 157.60.70.2. Subnet mask of /30. 252. Shut that bad boy. Let's see if we can ping the other side, ping the router, right? So I'm gonna have the switch right here, ping that router, and then we're gonna give them a virtual IP address, so that way these guys can reach their gateway. Ping 157.60.70.1. Can I ping it? Pray to the network gods, and we got a reply. Good to go. So the switch can ping that router. So we got the wide area network going here. Let's do the local area network. We're gonna say IP interface. Oops, go to global config mode. We're gonna give it a SVI interface VLAN 1, and give it the IP address of the gateway, which is gonna be 10.252.1 /24.252.0. Right, and then we're gonna do the DHCP pool for my man. Let's give him a host name. Let's give him a host name. Host name SW1. He said I found and post in GNS3 talking about this issue. Apparently, the issue is with VPCs. I recently started using Linux machines instead of VPCs in GNS3. That is rather interesting, Yuliang. That's crazy, man. Man, okay, so I'm gonna have to get some Linux machines, man. That's crazy. All right, I'm glad you Googled that for us, man. I thank you for that research, man. But yeah, I guess that is a problem with it. Let's see if that don't work. Then we just gonna have to forget about DHCP for now. But I'm gonna give him a DHCP pool, and we're gonna name it. What we said we was gonna name it 10-pool. 10-pool, right? The network is going to be 10.10.252.0 network /24, right? No, you can't do it that way. So you got to do 255. Can you do /24 like that? /24? No, you can only do. Oh, yes, you can. Good. So exit out of that. And y'all see just little things like that. I can't remember it, but because I'm like just going and just learning it that way, that's how you remember these little things. So lab with me, guys, man. Make sure you guys are labbing. You see how Yuliang, was able to find an issue just by doing a little bit of research. That's an underrated skill. Being able to, do a web search for specific topics or specific, problems that you may run into. Because somebody in the past, most likely, ran into that problem as well. Google is probably the best knowledge base in the world, right? Because you search and you're like, oh look, somebody ran into the same issue that I did, right? You're gonna look for anything nowadays, man. IP, what was we doing here? Oh, I gotta go back to that pool. What am I doing? Where's the network? The pool. We gave him the network address. We need to give him a gateway. So default router is gonna be 10.10.252.1. What else we going to do? Let's get out of this. And we'll exclude an IP address. So IP DHCP excluded address is going to be 10.10.252.1. So please don't hand that IP address out. Show our work with show IP DHCP pool. Where we at? Show IP DHCP pool. So it's looking the same. And see, the switch gives you the excluded address. So I guess it depends on which iOS version you're using. The router didn't do that. Remember when I went on the router and I did show IP DHCP pool, it don't give you the excluded address or how many there are. The switch does. So I guess it depends on which version you have. There it is right there. Excluded address is 1. We have total of 254 to hand out. Can these guys get one now? If not, then it could be what Yulian said. These VPCs can't get an IP address through DHCP. But I've done DHCP before and was able to get the DORA working. So I don't know. He said, got your back. Not sure if I can post the link here. I don't know if you can. Try it. It might get... Try it. See if you can post a link in there. But that would be very, very helpful, man. And just as long as you ain't sending us to the damn dark web with that link. So, IP, DHCP, pray to the network gods. Press enter. We got a D. We stuck at a D. And it don't look like he is going to get an IP address. Now we're stuck at the D part. Let's see. We might have to skip this part, man. But I want to get it working, man. I hate having to skip over and be like, oh, you know what? I couldn't get that working. Skip that. Nah, man. Like, we going to get this work going here. Is the interface up? I don't think it's up. It is up. It is not up. Interface VLAN 1. It's admin down. That's the problem. That's the problem. We need to bring that up. Let's do that. Global config mode. Global. Gobble. Go to global config mode. Interface VLAN 1. We say no shut. That should bring him up. Show IP interface brief. Exclude our unassigned addresses. So we got our local IP address. We got our public IP address. Interface VLAN 1 is up. Can PC3 request an IP address. We get on our knees. Pray to the network gods. Press enter. We got a D. We got an O. We got an R. We got an A. And that looks like it was a problem, man. The damn router. So we got an IP address. Good to go. 10.10.252.2. I don't know what happened with this router, man. We got to delete your ass, man. What is going on with you? We said it exactly the same way as... Man, listen. Bye. Boy, bye. All right, same thing with this switch right here. But these are just kind of bugs you run into with GNS3 and stuff like that. I'm glad I'm glad we were persistent with that, man. I'm glad we were persistent with that. He said it did not let me. It got deleted. Oh, okay. It's all good, man. Show protocols. Oh, yeah. I forgot about that, Pete. But, yeah, it looks like we got DHCP going. Let's get rid of router 3. We ain't worried about that guy no more. We got router 1, router 2, router 3, PC4, and then we got the switch. Let's have PC4 get an IP address now. IP, DHCP. Get on our knees. Pray to the network gods. We got a D. We got another D. We got an O. We got an R. We got an A. And we got an IP address. Finally, man. All right, I'm glad we was persistent with that, man. That was the problem, man. I guess something was wrong with that router. It could be a GNS3 bug. It got to because we did the same exact configurations on the switch. So I don't know what the hell was wrong with that, man. All right, so we got some DHCP going. Let's go ahead and just mark this side. So just to kind of say we got the whatchamacallit. Not that. What was I wanted to do? I wanted to put a box there. This is the box. That's not the box. I want to draw a rectangle. What the fuck? Okay, there it goes, right there. I will give that. That's just gonna denote that the local area network has been completed. We ain't got to worry about the wide area network because we know we're gonna work on that, right? It looked like I need to make this a little bit smaller. He said, excellent. Oh, yeah, man. Appreciate that, Lawrence. I hope you're freestyling on as well, man. I hope you have a lab going, and I hope you're kind of experimenting with DHCP and ACLs and static routes and stuff like that. Most of the gamer said, I couldn't even complete NAT. It also has a bug. Are you serious, man? Oh, all right. Well, we're going to find out. We're going to try to get as much as we can going with GNS3. It looked like I might have to stay away from GNS3 and get on that even G wave, man. But I've seen some people, didn't Pete run into some even G problems? CML seems to be the wave too. Cisco Modeling Labs, if you guys are not familiar with that. But let me see. I don't know if that has any bugs, but y'all know that is a Cisco proprietary application, so it should definitely work with their iOS and stuff like that. Let's fix his coloring. We're gonna make him not the border, but the fill color. Let's give him. We'll give him an orange, right, to denote that this network is complete. I'm gonna lower that bad boy. Y'all let me know if y'all can see everything. That is that network. All right, so I guess let's get some. This is supposed to be like that right there, right? That's that local area network. That side right there, right? This is the wide area network simulating the internet. Let's get some static routes going, right? Because obviously these guys are not going to be able to ping those guys unless we got some routes. We haven't done any BGP or OSPF or anything like that. We have like probably a couple months ago, but this week, like I said, Freestyle Friday is just going to be covering what we've done for this week, which just happened to be static routes. Static routes, as you know, is a route that you use to that you manually configure. It's something that you actually got to type in and say, to get to this network, take this next hop or whatever, right? Whereas dynamic routes, if you kind of do the same thing, but you're kind of like saying, if any interface falls into this network, add it to OSPF or BGP or whatever the case may be, right? And then if a network goes down or if a link goes down, like let's say this link goes down and we had another way to get there, it'll dynamically on the fly take you, give you another route if you have, you know, EIGRP or BGP or OSPF set up correctly, right? Because that's why they're called dynamic. They kind of like change on the fly, right? Just like women's emotions and stuff like that. But so let's go ahead and get some static routes going here. Let's go to Router 1 and let's have a static route. Let's take a look at his routing table so far. He probably just gonna know about his directly local area networks, right? Directly connected networks. What he know about? He know about the 97 network, which sits behind him right over here. He also know about the 192. No, my bad. This is the 97 network, and then the 192, which is the private IP address space. So he knows about those networks because they're directly connected to him. He don't know about this network right here. So we need to get that going. Let's go to global config mode. Right? We're gonna say IP route is how we start our static routes. We're gonna say to get to the 157.60.70 network, we could take either the exiting interface or we could use the next hop. We'll use the next hop at Kelvin's advice. You could remember, you could use, when you set up a static route, you can use the exiting interface and say to get to this network, take this exiting interface, or to get to this network, take the next hop of that. The next hop. We'll go with the next hop. So in this case, what's the network we want to get to? 157.60.70. You got to do the network, right? Subnet mask of 252.252.250. Not bad. Fat Finger Squad. It's 255.255.255.252, right? Take the next hop of 97.55.70.0 or .2 rather, right? Y'all with me so far? That is how we do a static route. Basic static route. Basic CCNA topic right here, right? 70.2. That is the next hop. Press enter. Let's take a look at our routing table. Before, we only knew about the 97 network, which is over here. We knew about the 192 network, which is over here. Why? Because they are C. C means they are directly connected to us, right? We look at this legend, it tells you right there, C. We only know about the connected networks, the networks that are physically connected to us with a cable, right? Now, we create a static route, so theoretically we should see a S in there somewhere, right? Let's do show IP routes and take a look at our routing table. We don't know about it for some reason. Am I on the right router? I am. I said IP route to get to that network, 157 blah blah blah. Take the next hop of that. Why did he not show up in the routing table? Anybody know why? Anybody know why? There should have been a that route should have showed up. Is it because I don't have an interface in there or what? Can I ping router 2? Let's do that. We should be able to ping router 2. I'm pretty sure. Take the next hop of. We said This ping router 2 is 97.55.70.2. He can ping it for sure. And we said that was the next hop to get there. Right? To get to that network, this right here, right there, we said take this next hop, which is that router right there. Anybody know why it didn't show up? I really don't know. I'm not pop quizzing y'all. Let's see. Show IP interface. I mean, yeah, let's take a look at our interfaces. Let's take a look. Let's look at our interfaces. Let's use Pete's command, favorite command. Show protocols. It's up. We got 192.168.1.1 is up. GI00 is down. What is going on here? Why do we not know about that route? Even though we said it. He said I mistyped the static route. I did? Fat Finger Squad in the building. What did I do? What did I say? I said IP route 157.60.0 subnet mask of this. Take the next hop of this. Really? Show run. All right, that should have showed up. I don't understand. How did I mistype it? Is it because I got to put in the .1 or what? I didn't press enter. 97.55. Oh, I did. I forgot the 0. Good point. I'm glad you caught that, man. I tried Signbox but couldn't set PCs. Yeah, I'm using Packet Tracer. Who caught that? Shout out to haha, you failed for the last time router. Moose of the Gamer, yeah, you was right. You was right, man. I mistyped the static route. So let's remove that and add a 0 at the, where's the 0 need to be? The 0 needs to be right there. We need to put a 0 there. So it's 57.70. So let's get rid of that. Let's go to global config mode. We're gonna say no this. And we'll put that route back. Control E takes you to the end. No, it doesn't. It does not. What is the shortcut to take you to the end? Control A takes you to the beginning, but how do you get to the end of a line? Anybody know? Is it control? It's not control E. It's not control E. Maybe it is control E and it just doesn't work because I gotta hold the right button right there. So it's 70.2. So shout out to Moose the Gamer for that. I put the wrong, I mistyped the route. So now let's take a look at our route table, and there it is right there. There's a static route. To get to that network, it's good to know that if you don't have an IP address, it's not going to show up on the routing table. That's good to know. That's good to know. I know that like if the interface is down or whatever, it ain't going to show up. But now we have it. So the S means it's a static route. That is how we get to that network. Let's see if this router can ping .2 of this network right here. Let's see if we can. This router, can he ping the switch over there? So ping 157.60.70.2. Probably not, because he don't have a route to get over there. Nor does router 2 have a route. So we need to. This is why static routes are not very scalable. You got to put it on a route for there, and then you got to go on the other side and put another route going back the other way. Bidirectional connectivity. So we got to go to router 1, router 2, and you'll see, we look at his routing table, same thing. He only know about his connected routes. He don't know about the routes back here, and he only know about this network. He only know about that network, but he need to know, what does he need to know? That's weird. But he definitely needs to know how to get back to that, right? Can he ping? Yeah, he can ping oh, see, this network right here basically doesn't really know how to get back to over here. That's what I think is going on there. But let's see. Let's do a static route going that way, right? IP routes, same thing, right? We're going to do our static route going back the other way to get to, not this network. We're not going to do that just yet because we're going to do some natting over here. My bad. This needs to be able to get over there. So I need to put a static route over there. We'll go to the switch. Where's that switch at? Right here. He don't know how to get to this network. That's my issue. So we'll go to enable mode, global config mode. So who tried to set up, he said it's control E. Yes, that's what I did. I did control E, but when you do control E, it creates another window like this. At least in Solar Putty it does. So it's good to know. I'm glad to know it is control E, but it does not work in Solar Putty. It's a shortcut to create a new session. So I'm glad you said that. Now I know. And no one's half the battle. IP address. I'm sorry, RIP route to get to the 97.55 network. So 97.55.70.0 network, subnet mask of /30. Take the next hop of 157.60.70.1. Let's take a look at our routing table, show IP routes. Now he has a static route to get over there. Let's see if the switch can ping that, and then after that we'll have the router ping that. Theoretically, it should work bi-directional connectivity, right? Ping 97.55. Damn, I got a headache. Fuck. It was before the stream, so I don't know what the hell's going on. 55.70.1. I'm sorry. Yeah, .1. And we got a reply. Good to go. Now let's have the router ping that right there. Oops. Ping 157. Oh, we already have it in there. Ping. We got a reply. Good to go. Pray to the network guys. We got a reply. Good to go. Good to go. All right. So, y'all with me so far? I know we're still on the static routes here. We're gonna create a. I'm gonna go with the ACLs next. No, we're gonna do some natting next. So theoretically, this PC should be able to ping PC4 and vice versa, right? So PC1 should be able to ping somebody over there. We should have the local area networks. We should have connectivity all the way around, right? Let's have PC1 ping PC4. Let's see if he can do that. Router, let's see, PC1. I don't know if he'll be able to do that. Let's see, ping 10.10.252. What was his IP address? What was PC4? PC4 is 252.3. Let's see. We got a reply. Nope, no we don't. We do not. We do not got a reply. Why is that? He don't know about those networks over there. Probably because that's what it is. This router does not know about that network back there. He don't know about that network. So we got to create another static route. Same thing with this. This one got to know about this back there. So in order to get over there, we can create default routes. Let's do that. Let's create some default routes. We're going to create a default route over here and a default route over there. And we're going to create the default route to be out of the serial interfaces. So we're going to create the default routes from router 1 and switch 1. He's supposed to be SW1. There. Right? He's also SW1 too for some reason, but he'll just be switch 1. Y'all with me so far? Return route? Yes, you're right. Here's the thing. We was able to get over here, but we got a reply from, we got an unreachable from where? Where was that unreachable from? I think from our gateway. Yeah, 1.1. He said, I don't know how the hell to get to the 10.10.252.0 network. I don't know how. So here's what we're going to do. We're going to create a default route on router 1. And say, if you got some unknown traffic, you don't know how to get there, take serial or fast Ethernet 00. So I'm going to go to router 1, create a default route. We also learned about default routes today too, so that's another topic I forgot to mention. IP routes quad 0, 000, take fast Ethernet 00, right? Y'all with me so far? We're saying any unknown traffic, send it out of that interface. We're going to do the same thing with this guy. Any unknown traffic, send it out that interface. Once it gets to the wide area network, these guys know what to do with it and send it there. So that theoretically should work. If not, then we'll find out why not. Go to global config mode. and we say IP routes quad zero, take GI 00 interface, right? We're gonna say any unknown traffic, send it out that interface. Ah, you can't do that. He said a default gateway with a default route without a gateway, if not a point-to-point interface, may impact the performance. Well, it is what it is because it is a point-to-point interface. So, and we don't have a default gateway. Let's see. Let's take a look at our routing table. What did I just do? What did I just do? I hope I didn't crash this thing. I put SIP. So hopefully that's not a real command. We did something there. I don't know what that is. Is that doing some kind of SIP trunk or whatever? I don't know what I did there. But it's getting stuck. Oh, it's doing a domain lookup. All right, so what's that? Control Shift 6? C? Okay, we got out of that. Good to go. All right, so show IP route. Let's look at his routing table. He has a default route. Good to go. We know about the 10 networks, obviously, which is over here. We know about the 97 network, which is over here. And obviously he knows about the 157 network is directly connected to him. Now, they both got static routes? No, I don't think so. Router 1 don't got no static route. Yes, he does. He does have a default route as well. Show IP route. So we have a static route. We also have a default route. So we got our default route. And we also have our static routes. Let's see if we can have... Can the router ping, let's say, PC3? What's PC3's address? 10.10.252.2. 10.10.252.2. So we'll ping that right there from router 1. Ping. Oops. Ping that bad boy. Don't look like it. Nope, he don't know how to get there. We have a default route, but he don't know how to get over there. So theoretically, that PC won't be able to ping these PCs either. Y'all see what I'm missing here? We can't have this router ping PC3. PC3 was 10.10.252.2. He can ping that switch though, which was 70.2. Let's see what happens. With 70.2. And y'all know, like, static routes, this is kind of like a routing nightmare because we got to create a static route to there, static route to there. It's like actually taking a map and drawing a line from a destination to a destination, as opposed to using a GPS when there's too much traffic over here, the GPS will change the routes on the fly. If there's a crash over here, it'll change the route on the fly. Whereas a map with a solid line onto it, it's pretty much akin to a static route. That is why it is a administrative nightmare when you're working with static routes. But it is a topic that is on the CCNA exam, and we got to know how to work with it. So if you don't know how to work with static routes, wait till you get to OSPF and BGP. BGP can be a really deep freaking subject. So let's try to get this going here. Router 1. What's going on with you, man? You don't know how to get to the 10.10.252 network? We said your default route is quad 0. Take this if you don't know what to do with the traffic. And same thing with him. Do we need to create a static route to get over there instead of a default route? Is that what we need to do? Because we have a static route and then we also have a default route. Maybe it's confusing it. What y'all think? This is what I'm going to do. I'm going to go to router 1. I'm going to get rid of that default route. I don't like that default route. I'm going to create a static route to back here. But then we're going to have to add some natting. So maybe we got to do the natting first. This is why we need to do the planning as an engineer. You can't just be freestyling this shit. You got to have, a change order. You got to have all this stuff planned out. But, this is how we doing on this channel. Y'all remember that like button. What are we missing here? Let's get rid of that. Let's get rid of that default route. I don't like that default route. Let's get rid of this. No. And we're going to say IP route to get to the 10.10.252.0 network. Take the next hop of 90 /24. 0. Take the next hop of 97.55.70.2. Right? So to get over here, take that right there. I don't know if that's going to work because that's 2 hops away. So I don't know. We'll see. Let's see. Let's just try that. And we got to do the same thing on the other switch. He got to say take 70.1. No, he got to say take that right there to get to that back network. So let's do that. Let's get rid of that default route. Oh, yes, I did. I got rid of that default route there. So we need to go to route switch 1. Did we have that default route? We did have that default route. Let's get rid of that though. Go to global config mode. We're going to say no this. And we're going to say IP routes. To get to the network 192.168.1.0/24 subnet. .0. Take next hop of 157.60.70.1. Right? Now, let's see if this can ping. I don't know. Let's see if he can ping the PC. Let's have the router ping the PC. Ping 10.10.252.1. Is that gonna work? I don't think so. Because there's 2 hops. Yes, it's unreachable. You got it unreachable. Huh. How can we make this switch get to that network back there? Anybody remember? How do we do that with static routes? I mean, this router to get to this network back here. The router 1 default gateway, Tune said, router 1 default gateway is router 2. Yes, it is. And that's what I ended up doing, isn't it? His default gateway is that right there. 97.55.70.2, which is that right there. So I said to get back here, take this as the next hop. But I think the problem is he don't know how to get back there. That's probably what I got to do. So router 2 need to know how to get back there to get to the 10.10.252 network. Same thing, right? 10.10.252.0 network. Take the next hop of 255. This is going to be a lot of, this is what I said about static routes, man. 255.0 network. Take the next hop of 157.60.70.2. Right? So from here to get to back there, he need to go to there. Is that correct? Right? So now he know how to get to the 10.10.252 network, show IP route. I think so, because now he got a static route there, and I think he need to know how to get back there for this to work. That's what I think got to happen, because he don't know. Obviously, he don't know about the 192.168.1.0 network, and then we might have to remove some of these static routes once we get the NATing involved, right? So let's try to do that. He needed to know how to get back there to get to the 192.168.1.0 network. Take /24 net subnet. Take the next hop of 97.55.70.1. So now he should theoretically have routes to that local area network, which is back here, and also the 10 network, which is back here. Okay, I think we kind of got this going here. But notice, yes, okay, that's good. That's good. 10.10.252.0 network. So I think we should be able to. I think this should work now. But notice, this is, like I said, static routes is an administrative nightmare. We got to create it to get to that network. Then we got to go to the next hop and be like, do that. This is why OSPF, BGP, and stuff like and EIGRP, those are better routing protocols because they're more scalable. Ping 10.10.252.3. What was PC3? I'm having this guy try to ping that guy right there. He's 10.10.252.2. See if he can ping that. What about router 1.2? Pray to the network guys. We got a reply. Good to go. So now theoretically the PC should be able to ping each other. Remote networks. So now go to PC1. See if he can ping 252.3. Who's that? Is that the PC3? No. PC3 is 252.2. .2. So he's supposed to be .2. Pray to the network gods. And we got a reply. Good to go. Even though we got this going, static routes, like I said, can be an administrative nightmare. We got to create it. We had to create a route to get back there. Then we had to get from here and create a static route to get back here. Then we got to do the same thing, vice versa. For this network to be able to get that network, this switch need to go know how to get back there, and then that router needs to know how to get back there, etc. We might have to remove some of these static routes once we get natting involved. So we're gonna add some natting on top of this, right? Y'all with me so far? Did I lose anybody, or y'all see how I got this? Finally got this working. Took a little bit of experimenting, but you know, that's what labbing is all about, man. We can't do this shit at work, right? We can't break our routes and stuff like that at work. So, you know, we're labbing every day at home, right? Let's have the PC. They'll have him ping PC4. What was PC4's IP address? The one that we got last time? It was there, right there, right? Show IP. He is 10.10.252.3. Oh, what was PC3 then? Show IP. Okay, he's .2. So he's .2 and he's .3. I should put some label in here. Let's do that. Let me get some label in here. 10, 10, oops. 10, 10, 252.3. Right? Is he .3 or is he .2? I can't even remember. I got a short-term memory. Y'all know what it is. I'm like Dory. I got short-term memory loss. 10, 10, 252.2. He's .2. Let's get it right, NetworkBruh. Let's duplicate that. And he's going to be .3. Y'all with me so far? .3. And then he is what was his IP address? What was his IP address? I think he was 192.168. He's 1.2. I believe he's 1.3, if I'm not mistaken. Yeah, he's 1.3. So he's .3. This guy's .3. Just so y'all can, in case you're just tuning in late or whatever, he's .3. And then the other guy's .2. That way I ain't got to keep looking. And he is .2. Right there. Right? Y'all with me so far? So we got the static routing nightmare working here. We need to, I guess, let's get some, do we want to get some ACLs going here? Get an access control list going here? And say who can access who? It's always good to revisit the basics. Faux show, faux show. Appreciate you for tuning in, you young. Yuliang. Where you tuned in from, man? I'm over here in the Central Florida area. It is 10 p.m. or at 9:10 p.m. Eastern Standard Time. We're going to give it about another hour or two before we turn this stream off and stuff like that. Let's see. We're going to go to, what do we want to get here? We want to get some access control lists going here. We'll set up Telnet and allow this guy to Telnet. He gonna be the technician. He gonna be the IT guy. So only he can Telnet to the switch. Let's try to do that. 192.168.1.2. How are we gonna do that? We're gonna go to the switch. Because we're playing with ACLs today, right? We're gonna go to the switch and say we'll set up Telnet right now. The switch is over here. We're gonna global config mode. We're gonna say line VTY 0 through 15. Transport input Telnet. We're gonna give it the password of not Cisco. Let's give it a little bit something. We'll call it bruh 5, all caps. That's the password, right? Let's see if PC1 can Telnet to it. The switch is, my bad, Telnet. Oh, does Telnet work? Does Telnet even work on there? I don't think it does. I don't think it does on the VPCS rather. Telnet into 10.10.252.1. No, telnet does not work on there. I actually got to do it on this guy right here. I'll probably have to create some loopbacks. That's what I'm going to do. Damn. Damn, see, you can't tell that. That doesn't allow telnet on there. Let's see. What does this thing offer? You can do a trace route. Let's say who can ping and who can't ping. Let's do that instead. We'll have router 1. We'll have router 1 telnet real quick. Just real quick. And I work for a company based in Austin. Okay, that's what's up. Florida, home of IT Pro TV. I didn't know that. Julian is in Mexico, Monterrey. That's what's up. I went to Mexico last year, just before COVID hit. I visited Tulum, Mexico, man. Beautiful, beautiful country. The best, no, not taco. Yes, I love tacos, and the tacos was great over there. But no, I take that back. That was in Colombia. What was it that I tasted that was so great? It was it was a shrimp taco. It was a great shrimp taco. But I was thinking of Colombia. But yeah, I went to Tulum last year, and VPCS are very basic. Yeah, they are. But yeah, I went to Tulum, very beautiful country. We did the catamaran boat ride. I did some whatchamacallit, the 4-wheelers. It was super fun, man. Super fun. Love Tulum, man. Want to go back sometime soon though, but right now it's not really a great time to travel. As y'all know, there's a worldwide pandemic and stuff like that, but it is what it is. So let's see if we can telnet into 10.10.252.1. Yes, we can. We said the password was bruh 5. Good to go. So he can telnet. Let's have router 2. We need to create an ACL to only allow router 1 on it. Because let's see. Can router 2 telnet into it? I'm sure he can. Go to global config mode. No, we'll just say telnet into 10.10.252.1, right? So I'm going to have the router 2 telnet in him. I had him telnet into the switch. Now I have router 2 telnet into the switch. Right? Y'all with me so far? So let's see if we can do that. Obviously, that's going to work. We said the password was bruh 5. That works. All right, so now let's say only the router can telnet into it. Router 1 can telnet, but not router 2. Right? We'll do that. What kind of ACL will we need to do that to make that work? To go to switch 1. We obviously got to go to global config mode, IP access list, and we're going to call it the telnet extended telnet underscore ACL. We're going to permit how do we permit router 1 if we don't necessarily have a management IP? He's probably using that. So 70.1. We're going to allow him to telnet, but we're going to block him from telnetting. So we're going to permit telnet or TCP. What are we permitting? The source address of 97.55.70.1 sudden mask of /30, but we're doing a wildcard bit, so it's 0.0.0.3. What are we doing with that? The destination is going to be the management IP of the switch, which in this case will be 10.10.252.1, and we're saying equals telnet. So we are allowing only telnet traffic. Right? Can you do it that way? Telnet equals telnet, right? Oh, the destination wildcard bits. We got to do the wildcard bits. So 0.0.0.255. Y'all with me so far? Permit host. Okay. Yeah, that's probably a better way to do it. Yes. Let's go with that. Let's go with that. Let's go with permit host instead. But we want specifically TCP traffic. Permit TCP host. The IP address is 97.55.70.1. Wildcard mask, right? Yes. No, you do the destination. You ain't got to do the wildcard mask for the source. So now you just go straight to the destination. Permit TCP host that destination 10.10.252.1 wildcard bits. We'll put that as the exact address. But then we might be blocking some of this traffic, some of this ping traffic. Let's see if we can still ping after that. We'll put that as the exact IP address. We're allowing only telnet with this, I believe. So we'll have to do a permit IP or permit IP any to allow all the other traffic. So equals telnet, right? And then permit. Okay, so now let's try that. So now let's have router 1 telnet into switch 1, right? Router 1. Why is router 1 listed as switch 1 right now? What the fuck is going on here? What is going on here? That's switch 1. That's router 2. They both listed as switch 1. What is going on here? The hell? Y'all let me know what's going on here. Do I need to reconnect? Oops. Let's reconnect. Let's reconnect. Oh, that's because I was telnetting into those guys. I forgot. Y'all see what happened? Y'all see what happened? I was like, why is he... Okay. So right now, we got to get out of this. We got to exit. We got to exit. So now we're on router 1. I'm going to exit out of this. Y'all with me so far? You have to apply the ACL to an interface. I'm glad you pointed that out, most of the gamer. Why do I keep forgetting that? Okay, switch 1. We got to apply that interface. We got to apply that ACL. We're going to apply it to the inbound interface of GI00. I'm glad you pointed that out, most of the gamer. I keep forgetting. That is something I need to remember. When you are creating an ACL, you need to apply it to the interface. This is something I've been forgetting since the beginning of me learning this shit, man. We're going to go to interface GI00. We're going to say IP access group. The name of it was Telnet ACL. That's the name of it. We're going to apply it inbound. Inbound. Right, so now the ACL has been applied to that interface right there, inbound. Shout out to Moose of the Gamer for that reminder right there. Now, let's see if we could actually telnet into it. Let's see, router 1. Can he telnet into it again? Yes, he can. Password was bruh5. Oops, BRUH5. It was supposed to be all caps, so BRUH5. He can work. Now router 2, can he telnet into the switch? What's going on here? Come on, router 2. Wake up, buddy. Bruh. I guess I need to reconnect him. Look like he's still getting hung up there. Maybe because I applied that ACL while I was in it. Maybe that's the reason why. Who knows? Musa on the ball. For sure, man. Y'all remember me that like button, man? And if you're just tuning in, we are just kind of going over the topics we went over this week. Typically, I stream Monday through Thursday, 8 p.m. Eastern Standard Time. Friday is just a new segment I'm starting called Freestyle Fridays, in which we just kind of go over the topics that we learned throughout the week, Monday through Thursday, lump them all into one topology, and just freestyle that mug, man. So far, we've done basic IP addressing, We did some static routes, so this network can reach that network. We're adding some access control lists. That's also another topic we learned today. Once we move on with that, we're gonna go on to NATing, which is network address translation. And if this goddamn router would freaking wake up, we'll be able to do that. But we'll be able to do some ACLs. But for some reason, I think it kicked me out because I was telnet into it, and then, come on, man, don't do me like that, man. There he is, right there. I'm thinking it's because I created that ACL, and then while I was telnet into it, see, router 1 is definitely up. Router 1 is definitely there, right? Exit, he's good to go. He's good to go. Router 2, I had a telnet session open. Maybe I need to, let me remove that ACL. If this is the case, then this is something I've learned here. Maybe I need to remove that ACL and then try to wake that switch up. So I'm gonna remove that ACL off this interface. Oops, interface GI00. I'm gonna remove this ACL, go back to the router. I'm gonna create a new session. Reconnect. Nope. For some reason, router 2 won't fuck with me, man. See, I had an open session. I had an open telnet session, and then I thought maybe because I applied that ACL, that's why it froze on me and it kicked me out. I don't know, but I'm reconnecting to this router now. He said, very enjoyable lab. I appreciate that, Pete. Like I said, I hope you guys are experimenting as well. Just kind of going over the same topics that we did this week. Y'all know typically we will lab from this book. This is where we normally get our kind of like get our topics from, right? We did, this book is called 101 Labs. You can get a copy of this from 101labs.net. Orders and link in the description box below. And each day we do a lab from this book. This week we did a lab. We did a static access. A static NAT lab. We did a lab on access control lists. We did a lab on static routes. We did a lab on network address translation. We did that Monday through Thursday, and that's where we got these. That's where we got those topics from, and we practiced those using this book here, right? Today, again, is Freestyle Friday, and we just kind of like lumping all those topics up because he gave us topologies to work with. He showed us how to cable it up. He showed us exactly what to do. But, you know, as a network engineer, you don't want to be a freaking robot. You're not going to have your boss telling you, hey, I need you to do this, do that, do this, do that. You need to be able to, you know, pretty much design your network and know how it works and understand those topologies. So us freestyling just like this right here helps us better learn those topologies and how they work and stuff like that. As y'all can see, I don't know what the hell happened with router 2 here, but it looks like it's awake there, and it might be because I had an open telnet session, applied the ACL, and maybe it locked me out. I'm not too sure. If that's the case, who knows? But now the router's awake. Now I think we can go back to switch 1, apply that ACL back on that interface. So I'm gonna get rid of the no here. Apply that ACL, and now I'm gonna have router 2 telnet back into that, which theoretically it should be blocked because we applied an access control list. Y'all know what that is, right? It's kind of like the bouncer at the club. He got an RSVP list, and it says who can come in, who can't come in, and that's what the ACL, you know, that is what that concept is similar to, right? So now router 2 is gonna try to telnet. I already have it saved in there. Into that, he's gonna try to telnet into that. Theoretically, it should be blocked because the first time it did work, but that's because we didn't have an ACL. Now we'll pray to the network gods, destination unreachable. So our ACL control, our access control list worked. Let's go back to router 1 and verify he could still telnet into it, which I think it should. Telnet, he can get in. The password was bruh 5 all caps. Boom, he can get in. So he can telnet into that, but he can't. So our ACL worked. Let's try this. Let's make sure we can still ping from this side to that side, because we created these access control lists. We say who could telnet and all this other shit, right? But we didn't say who can ping, right? Because remember, with an access control list, they have what's called, I'll show you the access control list. Let's go back to the access control list. Where was it? It was on switch 1, right? It was located on switch 1, right? I'm going to go to switch 1. We do a show IP access list. With this access control list, what do we do? Holy crap, we created another ACL. What the heck was all of this? What the heck was this? Is that what blocked our... That's crazy. I don't remember doing this, man. Oh, well, whatever. DHCP worked. So, that's crazy. That's crazy. I don't know what the hell all this is, man. Is that saved on my... Who knows? Who knows? I don't even know what that is. If anybody could tell me what that... It says pre-auth. That looks like it's a built-in ACL. Who knows? Oh, well. This is the ACL we created. We said with this ACL, access control list, we're going to permit TCP. What type of TCP? Well, we'll get that. We'll get to that over here. This is the type of TCP traffic. Telnet, or port number 23. We're allowing the host 70.1, 97, 55, 70.1, who is this guy right here, to telnet into the host 10.10.52.1. Who is that? That's the switch. That's what that access control list is. We got 178 matches. So all those telnets and pings and all of that traffic that came from here, he got these keep alive messages and stuff like that. That's what those hit counts are for. That's what that ACL does. But there's also what's called an implicit deny at the end. You're allowing this, but you're saying that's what's called an implicit deny at the end. You're saying, okay, you're allowing this, but all these other people can't get in. So it's like if we had a nightclub, right? And we said girls that's dressed in red can come into this nightclub. Well, the implicit deny is everybody else can't get in. That's what an implicit deny is, if that makes any sense, right? So we're allowing girls that's dressed in red. You got a red top, you got a red bottom, you got red bottoms on, you got a red bodysuit, you got a red, you got some red yoga pants. Y'all can come in if you're dressed in red. But we didn't there's an implicit deny, a rule that says anybody else that's not dressed in red can't come in. So theoretically, we should probably be blocking every other traffic. Let's see if PC1 can still ping PC4. I think we should be able to, though. Let's see. I think we should be able to. Ping, what was his IP address? We're going to have PC1 ping, is it lowercase? 10.10.252.3. Prohibitively, it says communication administratively prohibited. So I was correct. That ACL has what's called an implicit deny at the end. We let all the people in the red, dressed in red, all the girls dressed in red can come into this nightclub. But because we didn't say who else can come in, there's an implicit deny that says nobody else can come in. Nobody else can come in. So now we have to create a rule that's going to allow everything else to come in. So we're going to go back to the switch. And the easiest way to do that is to do something similar to this. An IP, but we're not going to say deny. We're going to permit. We're going to say permit IP any. Permit everything else. But that might let the telnet traffic in. We'll see. But that might let all the other telnet traffic in. Let's go back to that rule. And I'm sorry. What was it? We said, hold on. What he said? The ACL should allow all after the IP, allow IP any. Yes. So I need to go back in there. Good point, Musa the Gamer. Mario C said, one good reason is to always have an out-of-band serial connection to your devices. Yes, very true. However, this is virtualization. We're using GNS3, and I don't think I got any serial ports on these devices. But good point, though. P said, he laughing. I'm going to be in my CCNA exam thinking about your red yoga pants now. Hey, listen, I got a couple tutorials where I use that analogy. But, yeah, just think of the access control list. There's what's called an implicit deny at the end. Once you create a rule, if you don't specify who is allowed access, you're denying everything else. That's called the implicit deny rule. Y'all can look that up in any CCNA book, whatever. That's a really fundamental rule. So we need to create something that's going to allow everything else in. The name of the rule was IP access list. It was an extended list. And we called it, what we called it? We called it allow ACL. Where was it? There it is. We called it telnet underscore ACL is what we called it. Like this right here. Right? That's going to put us into named access control list mode, configuration mode. Right? Now, we got to create another rule that's going to permit everything else. Which is what, who said that? Was it Mario? No, Musa the Gamer. Yes, we need to allow IP any to allow everything else in, right? So we said permit IP, IP any, and I'm hoping that's gonna block the other traffic though. That's gonna permit everything else. Y'all want me that like button, and like I said, if I do have some bonus streams or whatever, we typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. But if I have a bonus stream, or if I said I ain't got shit to do, let me go ahead and stream tonight. I will let you know on the Discord server. Let me give you guys an invite so that way y'all know when I may cancel a stream, and it's very rare that I cancel a stream, man, because I've been pretty consistent here. Where the hell's the Discord? I just launched it. It looked like it's still waking up. It looked like it's still waking up. There it is right there. There it is right there. So y'all join that Discord server whenever I'm gonna. I was watching the concepts of your POE video. Let it autoplay into the next video, and I'm just realizing this is live and not a recording. Yeah, man. Appreciate you for tuning in, Anthony. Like I said, I haven't done those tutorials in a while. Maybe I'll get back into it, but I've been having a lot of fun doing these live streams. So, yeah, appreciate you for tuning in, man. But there's a link in the Discord server. If I do happen to cancel my stream, if you notice on the top of the banner of my channel, it says what time I stream, which is Monday to Friday, or Monday to Thursday, 8 p.m. Eastern Standard Time. But on Fridays, I'll do like what I'm doing today, which is Freestyle Fridays, and we're just gonna try to, you know, use the topics that we went over throughout the week and just kind of like lump them all together. So we created this rule that's gonna allow everything else in, right? So this is kind of like we did the telnet ACL. That rule is allowing the girls with the dressing all red, right? Where is it? Where is it? Let's do a show list, right? Show IP access list, right? So this rule is letting the girls in all red. This one is gonna kind of like let everybody else in. All right, well, you dress in black or blue, y'all can come in too. But this specifically says girls in the red can come in, right? If that makes any sense, right? So now, let's test the telnet first. Let's test the telnet again. I'm pretty sure it's gonna work. We're gonna get out of this. Go back to the router. So we're gonna telnet from here. Then we're gonna telnet from here. Then we're gonna have to ping from there to maybe there. And then after that, maybe we'll add some natting to this topology. Where router 2 at? There he is. All right, so router 1 theoretically should be able to telnet. He's good to go. We said the password was bruh5. He can get in. Now let's go to router 2 and see if he can get in. He should not be able to. Pray to the network gods. Hope he gets blocked. No, it allowed it in. Know why? Because of that permit IP any. We allowed everybody in with that rule now. So we need to fix that. We need to fix that. Let's get out of this. Bad passwords? Yes, we know. Get out. Get out. We need a rule. We need to get rid of this. Easiest way to do that. Notice it has a 20 beside it, right? I didn't put that 20 there. It is something access list that gets added to the sequence of your access control list. So this is sequence number 10. This is sequence number 20. If we add another one, it's going to be 30, 40, 50, etc., etc., etc. That's by default, right? Now, the way access control list works, it goes by order. And it says, okay, does this match? Yes or no? Okay. Then it goes to the next rule, so on and so forth, right? We can modify rules by removing them, adding them, etc., etc. We need to remove, obviously, rule number 20, which is allowing everybody else in. We don't want these girls dressed in black, these goth girls or whatever, and everybody else in. So we need to get rid of that rule. We need to create something specifically that's going to allow everything else in, but not the IP any. So what was the name of the rule? It was telnet ACL. So extended telnet underscore ACL. We're going to say no 20. That's going to get rid of that rule, right? Now, let's take a look at our rule. Show IP access list. So now we only got one rule there. We got 234 hits. How can we create a rule that's going to allow? That's what we need to do. We need to allow. What do we try to do here? Anybody know? I'm just now coming up with an idea on how can we allow these guys to reach these guys but still block him from telnetting into that. Anybody know? Most of the gamer got it correct. Bruh, allow ICMP. Exactly. I like that rule. Most of the gamer got it correct. So let's do that. Go back to the switch. Go back to that IP access list. Extended. We said telnet underscore ACL. And we're going to say permit ICMP. And we'll say anybody can ping this. Permit ICMP any. There. So now, with what we got so far, these guys should be able to ping those guys. This guy should be able to telnet in this guy, but this guy should not be able to telnet into that guy. Right? Let's start from left to right. We'll have PC1. See if he can ping 252.3, which is PC4. That guy right there, right? Ping. Boom. We got a reply. We can verify this also with the switch. Go to the switch. Show access control list. Boom. We got some hits. You see that? So shout out to Musa the Gamer for that one. And I came up with that rule. I thought about it, and then I looked over, and you did say that. Pete said, allow telnet from specific hosts, then deny all other telnet, then allow any. Yes, we could have done that too, but that just would have been this is a confusing ass ACL. I like the rule that we just came up with. We're gonna allow ping, and block telnet from router 2. So we did have a match here, and that was those five pings that we sent from PC1, right? 1, 2, 3, 4. 5, right? That's why we got those 5 matches. So now, router 1 should be able to telnet into that guy. Let's see if that still works. I'm pretty sure it does. He's actually still in there. Exit. We'll telnet into the switch. Password was bruh 5 all caps, and it works. Good to go. Let's exit out of that. Now, let's go to router 2 and try to telnet into it. Hopefully it gets blocked. Pray to the network gods, and we got blocked. Good to go. We're doing good with our ACLs here, man. I think that's enough ACLs. Let's get some natting going here, man. Network address translation. Unless y'all want to take a break. Again, y'all run me that like button. Subscribe to this channel, man. I know Anthony, you just now tuning in. Like I said, I haven't done those tutorials in a while. We've been doing mostly streaming and stuff like that. You said you don't want router 2 to telnet. And it can telnet at the moment, I believe. No, router 2 is being blocked right there. We just did it right there. See, watch, router 2. I'll double check though. Router 2, he tries to telnet to 10.10.252.1. Who is that? That's this guy right there. So he tries to telnet into it, and he's getting blocked. Destination unreachable. He could probably ping though. 10.10.252.1. He can ping it. See that? He can ping it, but he can't telnet into it. So thanks for making me double check though. So I guess let's get some natting going here. We might have to get rid of some static routes though because of this natting that we're gonna do here. So we have a private IP address space of 192.168.1.0 network. We got another private IP address space here. Then we have 2 wide area networks over here. Wide area network spaces. We got one there, and then we got one there. So this is gonna be some real tricky natting here. What we gonna do? How we gonna do this? I think what we would have had to have done is, see, this is a point-to-point network. We would need a wider pool to pull from if we're gonna do NAT Pool. I know what we'll do. The source interface is that. So we'll create a NAT pool of, we'll do a 98 pool, 98 address space. And then with this, we'll do a 158 address space. Shit, this is going to be difficult right here. Because we'd have to have 2 different NAT pools. This is going to be crazy, man. No, you good, Pete. You good, Pete, man. Thanks for, double checking and stuff like that. Y'all let me know what y'all want to do. This is, like I said, we freestyling here. We're just now, we done our static routes. We did our basic IP addressing connectivity. We created some ACLs. What I want to do now is we want to create a NATing pool. I want to be able to say when these guys with the public IP address exit out of here, they're going to have a public IP address. So we'll have to have when he, let's say, ping to this guy here. So we'll have to go to switch 1 and do something here. Well, the NAT pool will definitely have to be on router 1. But let's turn on some, we'll do a debug IP, not NAT. How did we do that last time? We did a debug IP ICMP. So now we're just gonna debug the ping packets. If that make any sense, right? So now when this PC, let's have PC1 ping that and see what comes as a source address. It's most likely going to be 192.168.1.2, right? So we'll have him, this guy, the IT guy, PC1, ping PC4, right? We do that. We got some replies. We'll go to the switch. And what we got? Did we turn on the debugging there? No, we did it on router 2. We did it on. He didn't do it there. We did the debugging on there. He's not pinging router 2. What I needed to do was on switch 1. That's what I needed to do. Let's do debug IP ICMP and ping that again. Take a look at the switch. No, that's not what we needed. Unless I ping the actual switch. Let's do that instead. I'll have the PC ping the switch. Then we'll see what the pinging looks like. The switch is actually .1, right? So now this PC is going to ping that. We have some debugging turned on, and hopefully it'll tell us who the source and destination is, right? Now we're pinging the switch. We go to the switch. There we go. That's what I wanted to see. Source is 10.10.252.1. I don't want that. I don't want that. The destination was this. So source was, what was it? 10.10.252.1. Where was it? And then the destination was this. Oh, that's when it came back. So, yeah, so the source is this. The destination was 1.2. I didn't want that. I wanted, because we got 2 public IP addresses there. This is going to be really tricky with the NATing. Especially because we got 4 different networks to fuck with right here, man. We got Professor Blackhouse in the building. He said putting in work. Yeah, man. We trying to get it going here, man. We did in case you're tuning back in, I know you probably went to go stream on your channel or whatever. Y'all join Professor Black Ops if y'all want to get into cybersecurity and stuff like that. Unless you was tuned in and you was just quiet this whole time. But if you're just getting back on, we got our static IP addresses working. We got some connectivity going from one network, the blue network, into the orange network on the right, and vice versa. We got some static routes going. We got some ACLs going with Telnet. I'm sorry. Professor Blacktop is into cybersecurity and stuff like that. He does his compliance checks when he tunes into our channel and stuff like that. So yes, we're using Telnet. We was able to block Telnet from one router and allow Telnet from the other router. What else we got? And now we're trying to work with some NATing here. We got a public IP address space. I mean, a private IP address space able to see the private IP address space. We don't want that. We want some private. We want some public IP addressing here. We want some public IP addressing here. We damn near 2 hours into the stream here, but it is what it is. Y'all know we have fun labbing doing this, man. Let me get some water here. Where my water at? Let me get some water. I need a little break here. I just thought about that shit. Damn, I've been streaming straight. All right. This is gonna be tricky. This is gonna be tricky here. What about creating additional links? From where to where, Musa? I like Pete's idea though. Static one-to-one NATing. So we can have this IP address NAT to something in another IP address space. We could do that. We could do that. But typically, static NAT is not used in a production environment. It's not very scalable because you're using one IP address and mapping it to one IP address. Same thing with the next IP address. So this PC, we made him 192.168.1.2. We might have him NAT to, let's say, he's .1 right now, but let's say he's let's say we NAT him to 97.55.70 .5, right? And then he's gonna be .6, and he's gonna be .7. That's still a waste of address space. It defeats the purpose of NATing. We want to try to conserve IP addressing. When we're doing one-to-one NATing like that, we're using IP address space, and it defeat the purpose of it. So that's why I wanted to create an IP NAT pool. But for this lab, yeah, it might be a little bit difficult to do that, especially because we put this as a point-to-point network, and we only have 2 usable IP addresses. And guess what? We use them motherfuckers. This is .1, and he .2. So we would have to create another IP address space to make it a pool, and then use that as the source interface, if that make any sense, right? But it could get really confusing. But that's why we doing Freestyle Fridays. So I like Pete's idea though, static one-to-one adding. But Musa, if you could kind of expound on what you said, creating an additional link from where to where, that might just throw this whole shit off. But let me do this. I'm gonna create a NAT pool real quick and see how that goes. I'm gonna try to do that. So I'm gonna go to router 1. Go to global config mode. Right? I'm going into this guy right here. I'm gonna create a NAT pool in here. And I'm gonna have this address space translate to a pool that like the 98 pool, 98.0 pool or whatever. Right? Y'all with me? So I'm gonna say, let me start with my outside and inside interfaces, right? Y'all remember we last time I forgot about it, and I was like, why is this not working? Why is this not working? Well, you gotta have an outside NATing interface and an inside NATing interface. So I'm gonna go ahead and start with that since that's the easy part, right? Interface FA00, right? 00. We know that this is gonna be my outside interface. So my inside interface should be somewhere in here, right? So I'm gonna make that my outside, this inside. IP NAT outside. But this is my question for y'all. So that's the outside interface. 01 should be the inside, or should that host be the inside? That's my question for y'all. Who needs to be inside interface? I think it's that physical FA01 should be the inside interface. Yes, I think so. I think so. I think that this should be the inside interface. So, interface FA, interface, Jesus, interface, oh my God. Let me get out of this real quick. Let me get out of this. Interface FA 0/1, right? We say IP NAT inside. I believe he need to be the inside interface. How we verify that? Show IP NAT, well actually, it's not show protocols. I know that's my favorite command, but that's not going to show you anything about NATing. Show protocols, right? That'll tell you nothing about NATing. Although it does show us the NAT virtual interface, but it does not show us who is the inside or outside interface. I think to verify that is show IP interface, blah, 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 right? So show IP interface FA01, not switch port, but just IP interface that. And then it lets you know. Nope. Nope, he does not tell you that that's who's NATing. How do we know what interface is NATing? We can do a show run, but y'all know I try to stay away from show run. We can do this right here, show run, right? FA01, right? And then we'll see we made him the inside interface. We know that, but we try to stay away from show run because we want to learn these other show commands and learn about the output. Because when we take the CCNA exam, CCNP exam, and all that other shit, they should give you show outputs and tell you how to, and tell you need to decipher this. What the hell is this telling you, right? Show run gonna give you the answers. So we try to use other commands. What is another command that I can use to look up show to look up some NATing information. I know show IP NAT translations. Nope, that's not gonna tell us. Show IP NAT statistics. That's it. That's it right there. So here's my outside interface. FA00. That's the outside NAT interface, the wide area network. And then FA01 is the inside interface. That guy right there. That's the inside interface. So that's how we do it. Show IP NAT statistics. I need to remember that. Y'all with me so far? Pete said, inside interface, facing the hosts. Yes. Okay, good. What else he said? What about loopbacks on router 1? Can loopbacks be used for NAT? I can't remember, but it gives you the address space. Yes, we could use the loopbacks. However, that's what we did with the lab guide. Remember, he didn't use actual hosts, if you remember correctly, or if I remember correctly. When he created these other networks like this right here, like when he created, like, let's say he created a 1.0 network, down here he created the 2.0 network. He didn't use actual PCs as the separate networks like we are doing right here. I wanted actual PCs just to kind of simulate a real network. He used loopbacks for the other networks. So, but that, yes, you could use a loopback. I just wanted to use actual PCs. So, so we did our inside interface. We did our outside interface. As Pete mentioned, inside interface is facing the hosts. Most of the gamers said just show IP NAT. Let me try that by itself. We did statistics. That definitely showed it. Show IP NAT by itself? No. But you was close. We actually had to add statistics to see who's outside and inside. So remember that. Unless that works in Packet Tracer or on a different platform, most of the gamer, point-to-point is fine with overload. Yes. But we did not cover overload this week. So that's why I don't want to use overload yet. Overload is the next lab, which I think we're going to cover on Monday. Yes. Challenge lab number 6. NAT overload. To this week, we only did static NAT and NAT pools. So, we got our inside interface. We got our outside interface. Let's create the pool. Go with global config mode, IP, NAT. Now, this is what I can't remember. What was it? You do the pool and then source? Or you do the source and then pool? That's what I couldn't remember. I think we just do pool. Pool. Right? And then the name of the pool, we'll call it NAT Pool 1. Because we couldn't think of anything more creative than that. And then the start IP address. What address are we going to pull from? Let's say we're going to say the 98 network. 98.55.70.0. Right? Just remember that. 98.55.70.0 network. So it's a different network. That's the start address. End address is going to be, we'll say .255, whatever. 98.55.70.255. Not a very large address space, but whatever the fuck. We going with that for now, right? Netmask, we'll say /24. Oh, but this is not going to reference the ACL pool, so we ain't doing it right. I don't think we're doing it right. I think we need to do IP NAT source, and then we got to do a list, and then we have to create an ACL. So we're going to create an ACL in a little bit here, right? So we'll just say NAT ACL 1, because we couldn't think of anything more creative than that. And we're going to say, we're going to specify the address or the pool. Did we do the pool first or the interface? That's what I couldn't remember. I think we're going to name the pool. And then we're going to do another, one, and then we specify the source interface. That's what we do. We got to do another line to do the source interface. We got to do the pool, then we got to do the interface. So in this case, the name of the pool is going to be NAT-pool 1. We're not going to do overload because we're going to do overload on Monday, right? And I think that's it right there for that one. Don't forget, we got to create that ACL. But before we do that, let's do the, let's create that pool. IP, now we can create that pool, right? This ties the ACL to the pool. But guess what? We didn't do an ACL yet, nor did we create a pool. So now we got to create a pool, and we got to create the ACL. So let's start with the ACL, I mean the pool. So IP NAT pool. No. What was it? IP NAT. Yeah, pool. Fuck. Pool. And then the name of the pool was NAT. What was the name of it? Y'all know I'm like Dory. I've got short-term memory loss. NAT-pool 1. And then what? The start address they want? Start address was 98.55.70.0. Ending address is going to be 98.55.70.255. Net mask of /24. Oh, we don't even have to do that. We don't even have to do that. We'll just do that. Oh, yes, you do. I thought he said it didn't matter, but we'll do it anyway. Net mask 255.255.255.0. Do that. So we created a pool. Now we got to create the ACL. All right, before we do that, let's show our work. Show IP NAT pool. No. How you do it? Statistics? Translations? No. Statistics. Yes. So we got the pool. Start address is there. Ending address is there. Did we do a source interface yet? I don't think we did that yet. The source interface needs to be that. So we got to create the ACL, the pool. We also got to define the source interface. I know I said stay away from show run, but I got to do it for now. For right now, show run section NAT. And let's see what we got so far. So we got our inside and outside interface. We got the pool. We have the ACL tied to the pool. We don't have a source interface yet. Right? I got to create a source interface, which is going to be FA. Is it going to be FA00 or 01? What is the source interface? Oh, okay. Yulian said, gotta go, bro. Keep the great go. Man, appreciate you for tuning in, Yulian. Remember, we typically stream Monday to Thursday, 8 p.m. Eastern Standard Time. And we're going to do freestyle. I'll try to do freestyle Fridays when I can, but typically I'm not free on Friday. So, but appreciate you for tuning in. And make sure you join that Discord server, man. Whenever I do happen to do a bonus stream. So we got the ACL. We got the pool. What is going to be the source interface? Does it need to be? I think it need to be FA00 in this case, right? I think this need to be the source interface. Correct me if I'm wrong. I want to resort to the book and see how they did it. Ugh. And I think after this natting, did we cover all the topics? I think we did. So I might be done with this natting after this. I'm holding on here, man. I'm getting sleepy and stuff. But let's see. See ya, yeah, man. While we figure that out, or at least while y'all at least help me out with that, I need to know what the source interface. I know we definitely need to create an ACL. We need to create an ACL. Go to global config mode, IP access list, standard. We'll create a standard list, and we're gonna permit. How you do it? I haven't done standard in a while. We're gonna call it NAT. Oh, that's what it was. We already had a name for it. NAT ACL1. That guy right there, right? And what is this rule gonna do? This is gonna permit the 192.168.1.0 network /24 subnet. Do we want to match? We'll log some matches. That's gonna definitely clue us in to it being working. So now we got an ACL. Let's show our work so far. Show IP NAT. This is an important one. Not NAT translations, but statistics. That is a great command right there. We need to look. We definitely need to know that one. At least I do. So we have our outside interface, which is that right there. Now we have our inside interface, which is this right here. What else we got? Outside destination. We got our access control list. We got the NAT pool. This is the address it's going to pull from. So whenever we use up an IP address, kind of like DHCP, it's going to say how many you used up so far. We only got 2 PCs on this network. So theoretically, we're only going to be able to NAT 2 hosts. What else we want to do here? I think we need to do a source interface. Once we do that source interface, I don't know if this need to be the source interface or that need to be the source interface. And you know what? That's what labbing is all about. I'm going to try both of them mugs, man. I think this need to be the source interface. So go back to global config mode, and we're gonna say IP NAT source list. Oh, we did that part already. We did that part already, right? Where was it? Yeah, we already did this part. But I wanted to say, I thought you got to have a source interface, though. I don't know. I don't think, do we need to do that? I don't think we need to do that. Source is 01 because it is the inside. That's what I was thinking, too. FA01. I think so. Do we need to do that, though? Do we need to do that? That's my question. Let's just ping and see what the hell, let's see what we got so far, man. Maybe we'll see what we're missing here. I'm going to have the PC ping the switch, see what happens. We got to reply. Go to router 1. We don't have no matches. Did we apply the ACL? No, we did not. We got to apply the ACL. Why do I always forget that? I always forget that. Go to router 1, right? Because look at the interface, FA00, right? Show interface, my bad, show IP interface, FA00. Guess what? We created an ACL, but we did not apply it. So we got to go to that. We got to apply that ACL to FA00, that interface right there, right? That ACL permits, who does he permit? I'll show you. Show IP access list. He permits everybody in the 192.168.0 network. So it permits everybody there, right? Go to AC router 1. We'll apply the ACL with global config mode, interface FA00, IP access. I can't remember if it's group or class. I believe class is for virtual lines. Group is for physical interfaces. So in this case, group. I tabbed over and I was able to see that. But I remember class from VTY lines, virtual class. That's how I remember it. I don't know what. Why did they do that? Why couldn't they just name it access list? Because that's what the hell it is. It's an access list. Why is it on physical interfaces when we apply it, we put access group, and then on a VTY line, we put access class? Somebody tell me that. Does anybody work for Cisco in here? Y'all tell me. I hate that. Do they do that to confuse us? Why the hell do they do that? They got 3 different names for access control lists. I don't know if y'all noticed that, but this shit confused me. But I'm finally remembering it, but I hate the fact that they did that. Unless somebody knows, maybe there's the history behind it. I don't know. My bad for my little rant there. I'm going Kwame Brown on y'all. But so we said access group. The name of it was NAT-ACL1. And we're going to apply it outbound, right? FA00, right? So the ACL is going to be applied outbound this way. That's going to permit the traffic going outbound. So out, right? Y'all with me so far? Now we show our work with, we'll check that interface, see if it's been applied. Show IP interface FA00. He said, Kevin said, ambiguity. ACLs are the object. Access groups are the application of the ACL. Okay. I think I see what you mean, but maybe I need to do, he said, if they did IP access list under the interface, that would get confused for the global. Oh, yeah, that's true. You're right. You're right about that. But you would think because you're applying an access control list to the interface, then, you know what I mean? Like, it should know. Like, look, I'm applying the access list, this access list to that interface. Why the hell they call it a group? But I think I see what you're saying by it being like a group. So it's actually less confusing to call it 2 different things. Okay, I guess so. I'll go with that. I'll go with that because, you know, we like to go with, you know, I I take your direction, Kelvin, because I take what you say into consideration a lot. So we'll go with that. So we'll see that. Where were we at here? The access list is applied outbound, right? Right there. So now that worked. What else we need to do? We need to have, let's go ahead and test it out, right? Let's have PC1 ping one of these guys right here, 252.1. Who's that? No, we're gonna have him ping the switch. We'll have him ping the switch because we're able to do some debugging on the switch and stuff like that. And he's still seeing that public IP address. We don't want that. We want a private IP address. Ping the switch. We got a reply. Put it in the network guards. Look at the switch. He still has the source interface of a private IP address. We don't want that. Oh, that's because the source is that. We want it the other way around. We needed to do some more debugging. What other debug command is going to show us? See, this is only deciphering traffic going that way, right? The source is 252.1. Who is who? Is a switch. Destination 1.2 is this guy right here. So he's only debugging traffic going that way. I want to see the source of this being a public IP address. Let's see. Let's look at the router real quick and see if he actually pulled. We did. Our access control list clearly worked. Did it? It changed the IP. Let's see. The access control list worked, but let's see if we got some translations here though. Show IP, NAT, translation. Nope. It didn't do that. The access list worked, but I don't think our natting worked. Show IP NAT statistics. Did he pull from that address? No, he didn't, because we got 0%. Maybe I got to do it again. Oh, I didn't do that source interface yet. Kelvin, do I got to put a source interface? Jason said, hello. Oh, appreciate you for tuning in, Jason. Are you just now tuning in? I haven't been able to keep up with everybody in here yet. Let's see. But I think I see what you're saying, Kelvin, because that is two different things, and I haven't really done much with like object groups and all that stuff. That all those the class maps and all of that stuff. So I guess that's the reason why they named them differently. I thought it would have just been, they should have just named it all access lists, but I guess that would make things a little bit confusing. So I don't think we put. Let's look at. I know I said stay away from show run. But let's look at actually what we got here. Section NAT. Do we have a source interface? We got the ACL tied to the pool. Do I need to put a source interface? We got ACL tied to the pool. We got the pool. We got an inside interface. We got an outside interface. I think I'm missing a source interface. I don't know. Y'all tell me. I wanted this address, 192.168.1.2, to get translated to something in 98 pool. So something from this pool right here. What am I missing? Am I missing something? Kelvin, do you see anything that I'm missing? I think I'm missing that I need a source interface. I think that's what I need. I want to resort to the book to see how they did it, but y'all know I'm trying to stay away from doing that. What do we need to do here? What are we missing? We might wrap this up after this. Once we get this natting working, I think we're going to wrap it up. He said call Kwame. Maybe Kwame gonna have the answers to natting here, right? Sprinkle some of mama's cooking and let us know why the fuck NAT ain't working here. So, I mean, it's we got the ACL, clearly it's working, right? Because we got a log right there. So it did permit 192.168.1.2 to ping the switch 252.1. That worked, but the access control, I mean the natting did not work, and I think we need to set a source interface. I think that's the reason why. Let's do that. IP NAT source, not list, not route map, not static. Static? No, it ain't static because that would have been static natting, and no, we don't want that. IP NAT source. I did that though. We did the inside, we did the outside, we did the pool. Is it source? Did that already. We tied the pool to the list. He said IP NAT source, name of the list, pool name, name of the pool. Yes, you're right, Moose of the Gamer, but that is what I had too. But I'm just wondering if there's like, do we need to define anything else? Because see, this is what I got so far inside, I'm sorry, section NAT. And yes, that's what I got there, Moose of the Gamer. You see there, IP, this last line right here, I think that's exactly what you're saying right there. IP, NAT, yep, source, list, or name of the list, right? And then pool, name of the pool. And that was it. Real deal on Phil said, I'm studying for CCNA 201. He just here to soak up some knowledge. I respect this channel so much. Man, I appreciate you for tuning in, man. I'm glad you respect this channel and stuff like that. And I love seeing messages like that. When people be DMing me on, like, you know, Twitter and Instagram and stuff like that. I try to stay away from, you know, the social media and stuff like that now. But I'll do get some, you know, DMs. And I'll log in every now and then, and people let me know, or just comments on my channel letting me know, hey man, I passed my exam because of your videos, and it's stuff like that. Just comments like that is what helps me to just, you know, continue doing this. You know, I ain't getting paid for this. I'm just, well, I kind of am now that I've monetized my channel, but it's not like I could replace my full-time job or anything like that. So I appreciate comments like that, man. Appreciate that. It makes me, it kind of humbles me, man. Thank you for that. Real deal on the field. But what the hell is wrong with this NAT? Something's wrong here, man. I'm gonna go ahead and look at the solution guide, and no, this is not a. Remember, we freestyled this. I came up with this topology. We did the natting. Well, so far halfway to natting. We did the static routes. We did the access control list. We tied a NAT pool to it and stuff like that. So all of that worked. But I want to remember this week when we did our NAT pool, there's something I'm missing that is not allowing me to pull from the NAT pool. So what am I missing? And this is something I'm definitely going to need to remember. And I'll probably remember this stream here. Be like, damn, that's what I forgot. Let's see. We could easily Google it. But y'all know I kind of use this book as a reference too. Let's see. The pool, when he created a pool, he did NAT inside source. That's what it was. Yes. And that's what you said, right? No, you didn't. You got to do inside source. And I think Kelvin, you gave us that as a clue the other day, right? Didn't you? Inside source? So yes, I was trying to. That's what I needed. The source interface. So I think inside source will be, like you said. Pete said it was facing the host. So I'm thinking that is my inside source interface. So in this case, IP NAT inside, right, and then source. That's what it was. List, and then so I think my statement was wrong. I created the pool. Okay, this statement is correct. This one is wrong. I needed to do inside source list. So let's get rid of that. Tie the ACL to the pool. I think that's what it was. I think that's the problem. So, IP NAT inside source. Yes, exactly what Pete said. Exactly. So, let's get rid of that. It was my natting statement that was incorrect. So, I got to do this, right? Put that back in there, but we're going to say IP NAT inside source. That looks better. We're going to have PC1 ping the switch again. We'll go on the switch, look at the debug messages, and see if it got translated. Or we could also go on to router 1 and see the translations with show IP NAT translations, right? And then after that, we should be able to call it a night. So let's go ahead and pray to the network gods. Go on PC 1. Have him ping the switch. Communication administratively prohibited. Something's wrong here. It looks like our ACL did not get allowed. Something is blocking it. Let's see what we got here. He permitted 1.2 to the default gateway. That we definitely fucked that shit up. We don't want to do an outside source. Let's see. Let's look at the switch. Nope, nothing happened there. I need to review this stuff. Hey, it's all good, Pete. We're all learning here, man. That is the point of us doing this, man. IP NAT. So let's see. Look, let's go back to that PC. That obviously did not go through. We got a reply from the gateway 192.168.1.0. So we got a reply from here, but it did not go through for some reason. So let's see. It allowed on the pool there. NAT inside source list. And that's what I thought you said. IP NAT inside source list pool name. And then we tied it to the ACL. And then the ACL permitted 1.2. But it did that. That was weird. Because NAT Pool 1 is definitely correct, right? This looked better, though. This actually let him through and did a translation. But he didn't pull from the network pool. Let's see. The pool is the 98 address range. What are we missing here? Anybody see what we're missing? Huh. I definitely want to get this NAT part correct. Once we're done with this, I'm going to end this stream. We're definitely missing something. And it's probably like one little step. And I thought it was because of this inside keyword. Because when we first left it as this, like this, when we just did IP NAT source list, ACL, tied it to the pool, NAT pool, that at least had some sort of translation. Or at least it allowed that IP address to hit the switch. But the problem here is it did not pull from the 98 pool. Let's take a look at our configs again. I know I said stay away from show run, but clearly I'm not great at natting. So section NAT. Let's take a look at this. Let's take a look at this. We got our inside interface. That's good. We got our outside interface. That's good. We have a pool, NAT Pool 1, and that is a subnet mask for it. We said IP NAT inside source list is NAT ACL 1. The ACL is correct, right? Let's take a look at that ACL. Show access list. Show IP access list. We got some matches there too. We said permit everybody from the 1.0 network. That's all we said. That's a simple list. And it's NAT hyphen ACL 1. So that's correct. We haven't done inside local, inside global, etc. I think that's for static. Static natting. And we're not doing static NAT right now. I'm doing a global, like a NAT pool. And you can see all of that with the show IP NAT translations, but we don't have any translations. So yes, we do. Oh, I guess it did translate. What the fuck am I? Look at that. Inside global was the 98. It did translate it. I guess it did work. And then inside local was 1.2. So hold up. Let's do this again. Let's do this. Let's do this. I'm going to clear the IP NAT translation. Star. That's going to clear everything. Right? Because we do a show. That's a good command for y'all to know. Clear IP NAT translations. And then star. right? Now we show NATs. We don't have no translation. So I guess it did work, but I don't think it was that the inside source. We need to get rid of that because obviously we got this prohibited, all this other shit right here. That obviously didn't allow us to ping the switch. So we got a reply from the gateway, but we didn't ping the switch. So let's do this. Let's go back to router 1. Go to global config mode, and we're gonna get rid of this IP NAT inside, and we're gonna say that's the one. No, that's not the one that worked. What was the one that worked? It was IP. It wasn't inside source. The one that worked was up here somewhere. Where was it? That one. Source list. We left out the inside keyword. We'll put that back. But let me see. You know what? I'm gonna do this. I'm gonna put this back. Try to ping it again. See if we have a translation. I don't think that worked. And then we'll try both ways, so that way we'll see which one worked. Right? Y'all with me so far? So I'm gonna put that back. Put that back. Put that back. Put that be back. Run that be back. Inside source list like that. We'll put that back. Now I'm gonna try to have the PC, this guy right here, ping the switch, boom, and hopefully we'll see some translations on it. And I don't think it'll work. Once we remove this inside keyword, I think it'll work, which it did, right? Because we did show IP NAT translations, and thanks to Pete for having us check the translations and saw that it actually worked. I think I'm using the wrong debug commands on the switch. That's probably the issue there. So ping the switch 10.10.252.1. No, that was from router 1. I didn't want that. I wanted it from the actual PC. All right, see? He actually got the reply there, but I wanted it from the PC. PC, he gonna ping 252.1, administratively prohibited. So that clearly did not work, right? Because we go in the switch. This was actually from the router, right? 70.1, 97, 55, 70.1. That was this. 97, right? You pay attention there. That was the destination. So when he got a reply, that was when I switched, when I had the router ping the switch. Now I'm gonna get rid of that inside keyword from that on that ACL, right? Go back to router 1. Go to global config mode. Get rid of this statement here. There's something wrong here. I don't know what that dynamic mapping in use. Oh, okay. So we do have mapping. Let's do that. Let's do that. So show, let's see, show IP NAT translations. Oh, we did get a translation, and he pulled from there. But for some reason, it didn't allow us to ping the switch. Or did it? It did ping the switch. Because see, look, outside global 10.10.252.1. So it did work. Good to go. But it didn't, I don't think that ping replied, though. I don't think that ping replied. Y'all see that? Y'all see that? Pete said on the interface. IP NAT inside. Yes, I do have that. Show, run. Oops, my bad. Go back to the router. Good question, though. Show run interface FA0/1, right? So you're saying on that interface right there, I need to have that command, right? There it is right there. IP NAT inside. So we did do that. And I did do the outside natting also. So we have that as the outside, the inside interface. We have this as the outside interface. So inside, outside. Now, well, my question is, how come we got these translations even though I don't think it allowed me to ping? Because see, we got this administrator. Oh, probably we got an ACL on here that's blocking the ping. No, we should have been able to ping. We was able to ping, but we got a reply from there. It's something that's causing this, but I think it is. Let me see. Is it pinging? No, it's not. It's not. Cause see, look. See, the time is 2:18, right? Oh, we'll clear the screen there that way. I'll have the PC ping the switch again, right? administratively prohibited. Go back to this switch right here. No replies, even though we have debugging turned on, right? Right? Show IP debug, or is it show debug? Show debugging. That's the only thing that's turned on. IP packet debugging. There's something that we needed to do. We got rid of that inside keyword, so let's do that. Let's do what I was gonna do. Go back to router 1. Clocking out, Anthony. It's getting late for me. Hey, I appreciate you for tuning in, Anthony. Again, we stream Monday through Thursday, 8 p.m. Eastern Standard Time. Today's just a bonus Freestyle Friday. Y'all make sure you join that Discord server, man. If I do, I typically don't stream on the weekends or Fridays or whatever. But I said I'm going to try to get in these Freestyle Fridays where we just kind of lump up all the topics that we learn and try to practice those theories there. So this is what I'm gonna do. Where was that? I'm gonna get rid of this. That's what we said we was gonna get rid of. Go to global config mode. We said we was gonna get rid of that, and it's gonna. I said there was a dynamic address and use. So we have some public IP addresses and mapped to some private IP addresses, which is this right here. This is what they're asking us about. It says, hey, we got all this stuff mapped up. You sure you want to clear this out? Yes. Because I need this shit to work. So let's do that again, but we're going to get rid of the NAT inside, and we're just going to say source list. That should tie the ACL to the pool, like that. And now let's have him ping the switch. So now he got a reply. We don't have that communication administratively prohibited. The switch obviously is getting some replies, but he's still seeing that private IP address, and I didn't want that. We go to the router, we do a show IP NAT translations. See, we don't have no translations. It's something that's causing this, and I'm not sure what it is. But see, it's allowing. It's causing. It's allowing. That's crazy. It's something I'm missing. I don't know what it is. The inside translation did work, but it doesn't allow. I think it's the ACL that's on the switch that's causing this. No, because he's allowed to ping. He's allowed to ping that. I don't know what's causing that. I do not know. Do y'all see it? I don't know what's causing that, man. So, damn. Yeah, I think that's gonna be it, man. I'm clocking out too, man. I might lead this up. I might save this topology. Maybe that's probably what we'll do. I'll probably experiment with it tonight. And once I figure it out, I'll stream tomorrow and let y'all know in the Discord server how I figured it out. I don't want to hold y'all up too long. And he said 252.1 is the switch itself. It will set itself as the source for the echo reply. Yes, you're right. But remember yesterday when we did something similar, we was able to see the other way around where this was the source and that was the destination. What show command did we do, or what debugging did we turn on to do that? We turned on debug IP packet, which is what we got on here anyway. So, but he definitely did an access control list and definitely did IP NAT inside source. He definitely did that. I think this is what I'm going to do. I want to try this. I don't want to give up. Just like we did with the DHCP, we was able to get that working because we did not give up. I'm going to remove that ACL that we have on here. For now. I'm going to just remove it off that interface, right? Remember we created this ACL right here? I'll show y'all. So, IP interface GI, interface GI00, right? We have that ACL, that telnet ACL. And that ACL says show IP access list. That ACL is allowing traffic telnet traffic, and then it's permitting the ICMP. I'm just gonna take it out altogether just for now and see what's gonna allow them to come in, because this ACL is, yeah, it's allowing ping from everybody. So let's put that inside source list back. I'm gonna put that inside source list back. Go back to router 1. I don't want to give up just yet, man. I don't want to give up just yet. Y'all know I love this shit, man. Let's see. I'm gonna get rid of this. No. So there's no dynamic mappings. We know when we add that inside keyword, we get some mappings here. So that's definitely working. But I think maybe there's an ACL. We need to remove that ACL that is going inbound here. I want to take that off for now. Go to global config mode, inside interface GI 0000. We're going to say no IP access list or access group. And the name of it was what? Telnet ACL? Yes, that was the name of it. I'm going to remove that ACL. I'm going to remove that ACL right here and see if that does anything. No IP access list. Oh, it was inbound. We'll put it back later. Go back to router 1. I'm sorry, PC 1. Try to ping the switch. Administratively prohibited. So that's not the issue. That's definitely not the issue. In fact, he's not even getting any hits. I'm gonna put that back. We're close. We're close. We're right at the finish line, man. We're right at the finish line. Because look, we got some translations going here, right? Show IP NAT translation. We definitely got some translations, but for some reason that ping is not going through. I don't like that. I don't like that. See, so we're definitely permitting that, but then it does this right here. This is the issue. Let's do this. There was something else I wanted to check. Do I need to allow that ACL is allowing it? Maybe because the ACL is outbound, and we need to allow it inbound as well. That could be it. Let's look at that access controller. Show IP access list. I think it's the access list that's causing this shit, man. See, we only got 13 matches. And we applied it. Where do we apply that ACL? We're permitting everybody on that ACL. FA01. Show IP interface FA0/1. We apply that access list. Oh, we didn't do it on the inside. No, we didn't put it. We put that access list out here. What happens if I put that ACL over here? Let's do that. Let's do that. I think it should still do it though. Interface FA0/1. IP access, and that's what labbing is all about, right? Access group. The name of that ACL, he said, was NAT ACL1. We're gonna apply that outbound or inbound. I think that's gonna be an inbound because we did it. Where we did it, I think we did it outbound on the other one. I think that's the reason why. It should have been inbound. Maybe that's the reason why. Inbound on this side? No, because it worked. That ACL worked. But we'll try it again anyway. Prohibited. Prohibited. Let's how about this? Go back to router 1. I'm gonna remove that ACL on FA00. FA00. And we're gonna say no that outbound, right? Show IP interface FA00, and then we'll say include access. So 00 does not have an interface. I mean, access control list. 01, which is this one right here. Let's see if it has an access control list. He does. And it's inbound. It's allowing traffic to go through this way. That's what I would assume. That's what I would assume. Try to ping again. Timed out this time. We don't want to make it outbound. So now we got a timeout. Did we set outside global? I don't know what you mean by that. I definitely set FA00 as the outside, the NAT outside interface, if that's what you're asking me. So for example, I do show IP NAT translations. I'm sorry, not translations, statistics. And we'll see that FA00 is the outside interface, this guy right here. And FA01 is the inside interface, this guy right here. If that's what you're asking me. We definitely allocated an IP address. And we definitely have some translations. So the translations is working for sure. Show IP, my bad. Show IP NAT translations. See, that's working. And it's pulling from that 98 pool that we created. It's just for some reason. Does this have to? Nah, we ain't got to do natting on this side as well, do we? Does anybody know? He's back to the textbook for me. Hey, it's all good, bro. We're learning here. That's what this is about, man. That's what this learning environment is about, man. But I'm gonna wrap it up in a second. I don't know what's causing that. He can ping. He was able to ping though, right? That's PC2. See, he's getting a. See now, if he tries to ping, this is PC2. So I've been doing it all from here. Let's try to do it from there. We haven't bothered him in a while. Ping 10.10.252.1. See, it's getting a timeout too. So we're getting stopped right here. Even though that access control list is permitting 1.3, is permitting him. Maybe we got to apply it on both sides. I don't think so. I don't think so. But that ACL allowed him to ping that way, and then clearly it timed out when he tried to ping the switch. Oh man. Oh, y'all see what time it is, man. 10:40 Eastern time over here, 10 p.m. But I want to get this going. I just don't want to give up, man. I just want to figure this out. PC2. Let's go back. We know the problem is definitely on this router. It got something to do with access control listing. The natting, the translations is clearly working. I think it got something to do with the ACL. What if we? Nah, we don't want to remove the ACL. We don't want to do that. Let me put the ACL on both sides. Interface FA00. I'm gonna put it outbound on that side. On the FA00 interface FA00. IP access list, access group. The name of it was what? NAT ACL? NAT ACL 1, like that. And apply it outbound. That's gonna allow everybody in the 192.168 1.0 network to go outbound. Because now I don't remember having to do on the labs that we did this week, having to apply that ACL both ways. I don't think so. Let me see what he did. When he did it, he did IP NAT inside, IP NAT outside, and his access control list, it just, I don't even see where he permitted that access control list, or at least added it. No, I don't even see where he added it. NAT Pool. He created the pool. He created an access control list. And then he tied that access control list to where? I don't see where he applied that access control list. ACL 1. Should have been not the loopback, not the physical interfaces. He didn't even apply the ACL. What the fuck? So why would we even create an access control list if it's not applied anywhere? That's my question. That's what he did last time. He said, I'm not convinced the translations are 100% working. You don't think so, man? I don't think so either, but I'm going to remove that ACL altogether. All this right here. Let me get rid of that because he didn't even apply that ACL on the labs from this week. And I thought he did that. I'm going to do that real quick. Interface FA00. No IP access group. NAT underscore hyphen ACL 1 out. I'm going to do the same thing on FA01. No IP access group. That was inbound, I believe. That was inbound. So now let's do a show run real quick. I know I said stay away from show run, but I want to make sure I see everything. Everything. There's our ACL, which is weird because it's not being applied anywhere. We have the ACL. We didn't apply it anywhere this time. Because that's what he did. He didn't even apply it. So I don't understand what's the point of creating that ACL if you don't apply it anywhere. That's weird. We'll see. Unless it's a typo in his book. Let's see. But at least we'll understand that concept when it comes to tying the ACL to the pool. So maybe you just don't have to apply it in the interface. Let's see. I have PC1 ping the switch again. You know, I did that a million times. We got a timeout. So no. We're not even allowing. We're not even allowing it. Last time we had the ACL, how do we apply that ACL? And it worked. At least we got a reply. At least we got this right here. I think we applied that ACL outbound this way when it worked. We got a pool. Let's see. Show IP NAT translations. You're saying, look, this got to work, man. Look, because we have outside, inside, local, all this stuff. But my question to you is, what am I missing? Why his replies are not coming back? Because he's getting replies from the gateway. This right here is letting him know, hey, that communication is administratively prohibited. And then the switch obviously is not, it's not getting those replies. See, watch. If I clear the screen, if I send a ping, well, now the ping is not working. So they're being timed out. They're being timed out because of that access control list. Let's do show run real quick. Where's my access list? That's my access list. And I logged it. It's not applied anywhere. This feels like it's the troublesome command here. Yeah, natting has always been a weak point of mine, and that's why I'm kind of drilling hard with this, man. I got to do this more often, clearly. Let's stay on the router. I'm going to give it 5 more minutes. If we can't figure this shit out, I'm calling it a night. So, I'm going to apply it on the outside interface. Is what I did, right? Last time, FA00. We already made him. FA00 is the... Where is he at? He is the outside interface. IPNAT outside. And then the other one was IPNAT inside. But then I think you got to apply that ACL somewhere. But see, when he did the lab yesterday, when we went over it, he created an access control list tied it to the NAT pool, but he did not apply access control list number 1 to anything. That's what I get confused about. Oh, you ain't got to change the source interface. That's because he wasn't using PCs. He wasn't really using PCs. That's right. His was different. He used the actual router and just went and did it that way, right? But we're not gonna have any. We don't have any loopbacks or anything like that to kind of do that. So it may be just because of the change. I don't even know, man. I can't even call it. Let's create a loopback. I'm gonna do this. I'm gonna create a loopback and do 1.1.10. I'm gonna do that. I just got an idea. Oh, first of all, we need to go back to that interface and apply that ACL, right? No, I don't think so. I don't think so, because he didn't create that ACL. I'm gonna do this. Interface, loopback, 10. Right? I'm gonna give him the IP address of 192.168.1.10 subnet mask of /24. Is there an implicit deny on the access control list? Yes. Theoretically, all access control lists have an implicit deny, but when we didn't even have that ACL, we was able to ping from here to there and vice versa. We could even have this PC ping that guy. And then we had telnet traffic. If you're just tuning in, we was able to telnet from here to there, and we created an ACL that's gonna not allow him to telnet to that. So, but yes, theoretically, all access control lists has an implicit deny at the end. Yes, that's correct, Courtney. I'm gonna say IP address list. IP address list. I must be half asleep or something. .0, right? I created in a loopback. Oh, you can't even do that. Interesting. See, you can't even put. I can't even create because of this right here. That IP address is .1 and it overlaps, so I can't do that. I could probably have the PC with .10, but I can't give him that IP address. He got to create it in another network. And our ACL is only allowing the 1.0 network. 192.168.1.0 network. Huh. I don't know. I might experiment with this a little bit more tomorrow. And once I figure it out, I'll let y'all know in the Discord server. But I'm half asleep. Y'all can see I can barely think right now, man. I streamed for what? Damn near almost 3 hours and shit. So if y'all like what y'all see, man, y'all run me with that like button. Make sure you subscribe to your boy. I'm going to figure this out. Don't trust me. I'm going to figure it out, and I'm going to let y'all know in the Discord server how I figured it out. But for now, comment, like, subscribe to the network.